p.m. in Germany and noon in Eastern North America. So if I can find where my cursor is, PowerPoint is hidden there. There we go. I can actually click on share screen and we can start. All right. The question is which of my two screens can you see right now? Can you see the one that looks like a big slide saying experiential learning, or can you see the other one?
I see the slide.
You see the slide? Okay,
yes.
Good. All right, that's very good. Okay, and you should also see here is just a couple of links. You should see, it should say upcoming and recent presentations, right? Just want to make sure that everything's good there. Good. All right, well, let's get going. Welcome, everybody. My name is Tim Lethbridge. I'm going to just bring PowerPoint back. There we are. Right, so I am a professor at the University of Ottawa. I've been teaching here initially part-time when I was doing my PhD and then full-time for 30 years now. And my specialties have been usability, software modeling, software engineering education. And I'm actually on the steering committee of this conference. For the last 12, 13 years, my focus has been on this tool called Umple. I've always done research into tools, and many of those tools have been applied to education, but I've also applied this tool work to industry as well. So this is, although a tool focusing on the educational aspects of Umple, the technology is not designed just for educational use and is indeed being used in industry. I know, for example, that there is a big bank in the United States, unnamed, who is using it because they have contacted me because they keep telling me about, well, you got to fix this security problem, and I fixed them all, or my team did. So we know it's being used in industry as well. All right. So, so the outline for this talk today, I'm going to first give you a little bit of motivation for why we decided to really focus on this topic. Okay. Why do we want to? What are my motivations for Umple? Motivations included both for educational use and also for the use in small teams, open source teams. There are big, expensive tools for big industry for software modeling, and they're not so easily usable by small teams, and certainly not by students. Then what I'm going to do is I'm going to give an overview of Umple, the technology itself. And as you'll see, that scans a lot of slides from slides 11 to 72. But in fact, during this discussion of Umple, I'm going to give you demonstrations of how I teach various software engineering concepts throughout the slides. Towards the end, then, we'll wrap up by discussing or summarizing how, first of all, in section 3, I use the technology for teaching introduction to software engineering. And then we'll talk a little bit about how I've also used the technology in the capstone course. In fact, the majority of people who've developed the technology have been capstone students. All right. So, motivations. 3 major categories of motivation for using, for motivating me to develop the Umple technology. And I say me, but I mean my team. Excuse me. First category is I wanted to teach agility better. I wanted a tool that fits in with the agile mindset for software development. As of the time we started this, a lot of the modeling tools, a lot of the tools out there really were more waterfall developed. Big models, big requirements, get them right up front, big design, get it right up front, hard to maintain, you might as well get it right. I wanted a technology that would allow us to work with small increments more easily. And so I wanted a technology which I could teach students about agility, but yet would do all of the other kinds of things. I wanted a technology that allowed for the frequent releases, continuous integration, issue tracking. A lot of the existing modeling tools didn't really integrate well because they focused on diagrams. And yes, they had a textual format, which was, XMI, XML, but that doesn't really work well when you want people to comment on things. So it needed to be textual to work well with Git, for example, and other version control systems. But at the same time, the diagrammatic notations are fantastically useful for getting overviews. So it needed to be able to support both, and that was a key part of it. So once you have a textual notation and you can blend in with these, with the standard technologies for things like, well, Git technologies, then you can do branching, and you can have branches of your models. You can have pull requests, traceability back to issues, because people can see where things came from, what requirements they came from. You can do comments on diffs, inspections. People doing online inspections was starting to happen 12, 13 years ago. And you can then move into lean documentation as well, because the documentation can be blended in with your repository. Okay, and I also wanted test-driven development. So I wanted to be a modeling technology that would blend in with the then developing test-driven development concepts. We see it everywhere today, right? We see JUnit and CPP unit and so on. But I wanted modeling to also have test-driven development. And I needed projects and methods to go along with all of this. So that's the first one, and I've coded that red for these 3 slides. The next one I've coded blue. Yeah, we need better tools for modeling. And for those who say, well, what is modeling? It's design abstraction, right? So all branches of engineering have design abstractions, and that's a key part of the community I'm in. And I've been involved with UML and UML tools for some time before that, but UML has some weaknesses. Basically it's diagrams, and as I said, I wanted other approaches. And it's clear that big companies are using modeling quite extensively. That telecom companies, automotive companies, aerospace companies are doing modeling. Maybe not UML necessarily. Maybe they're using Simulink and things like that, but they are doing modeling. But smaller companies aren't. And then in education, what you get is a hodgepodge. You get some educators teaching with drawing tools, some educators teaching with tools that were at one point considered very good, but in actual fact, in industrial practice, don't work very well. And in particular, a lot of these tools, the industrial tools do code generation, but the tools that are being used in industry have some combination, so in education, have some combination of these weaknesses. They're either expensive, you have to pay $1,000 a seat per year for some of the very expensive tools, or they're excessively complex. Now, Papyrus is an open source, it's the dominant open source tool used in industry, but over and over again, we hear that it's excessively complex and remains so. And generate poor, incomplete code. Now, not all of them do. There are some good code generators out there, but then they're complex, right? So we want a tool that's simple and generates good code and is essentially free and also blends well with agility. And this is really the kicker. I want a tool where I can do everything I can do with code, but with models. And then the third pillar of this is feedback. And we hear that over and over again. This is the experiential learning thing. I need students to be able to actually build software using models in an agile way, right? A lot of modeling is being taught in universities. Or here's a little example. Here's a picture of UML on the screen. Here's the syntax. Here's the semantics. Toy problems. Theory only, just syntax and semantics. Maybe a little bit of, well, you could do it this way, you could do it that way. But they by and large, don't get to build real systems. Or maybe, if you're lucky, they get a couple of labs in Papyrus, but they get daunted by learning the tool, and the students say, oh boy, I learned the tool, I can put it on my CV, but, well, they really haven't got very far into it. And a lot of the tools don't give real feedback. In other words, well, here are the 100 things that could go wrong with your model. Here's, you've got a cycle in your inheritance hierarchy, or you've got type mismatches and so on. Now, compilers give feedback. Many compilers do it with strong typing, but there's many other kinds of feedback you get from compilers and programming languages. We should have exactly the same kind of thing with the same level of usability in a modeling tool. And then students will be able to say, you know what, I get it now. I understand why my model is wrong. Whereas what I was finding before I developed Umple was that students would get marks wrong on an exam and say, I wonder why. Well, you know, you didn't use the right multiplicity. Well, how would I know that? You know, they need to learn by getting feedback and correcting their models. And a lot of the examples that were being used were toy systems. So I wanted to be able to build some pretty substantial systems, which students can then learn from. That really work. Whoops. One more point I wanted to say here. And so this notion of the fix/redesign retry loop is important for students. Now, there are some people who disagree with that. Some people say, well, you should try as a student and get your program right first time. And I remember, you know, taking courses in fact, at this conference, right, on how to train students to get their programs right so they don't have bugs the first time they compile them. And yes, you know, as you become an expert, you can write. I can probably sometimes write a 100-line program that doesn't have a bug, but it's pretty rare. Most of the time, you get feedback and you fix. And sometimes you get feedback and you have to redesign because you realize that your design was crap. Well, we need this in modeling as well, right? And students need to learn from failure as well. Sometimes you built a model, you can compile your system, but then you realize that it actually doesn't solve the problems. It doesn't do what the user needs, doesn't solve the requirements. So we need feedback on working systems, experiential learning for students. So we've got all three of these pillars to think about. Where did I get all this knowledge from? Well, a lot of it was personal experience teaching students, but we also have done quite a body of research into this. Some papers have been published at this conference in various journals. Here's just a few. The first one I'm going to talk about for a couple of slides. The latter ones, there's a double L there, so that link probably won't go to the right place. It's publications.umple.org should take you to the link. And anyway, yeah. So let's take a look at a survey I did. So this was a survey I did with a collaborator in Brazil between 2017 and 2018. We had a paper in this conference and a paper in the SOCIM journal on two aspects of this. One was a survey of students and another was a survey of professors. So what you see here is the professors in green and the students in blue. Very strong correlation between them. What do they want in a modeling tool? Well, they want it to be simple to learn, free, simple to install, and support the most important notations. That doesn't mean all the notations. So UML is super extensive with tons and tons of notations and subnotations and rules and so on, but the most important ones, right? And then behind that, we have code generation, which a lot of tools don't do or don't do very well, interaction with other tools, and so on. So essentially, we built Umple before this survey, but this survey kind of backs up some of our thinking. We did do surveys back in the 15, 20 years ago, which also lead to some of the same directions. And here are some of the weaknesses that people find in tools in general that are out there. And the first one on the list, and this is from the students, notice the students are blue, is tools don't give sufficient feedback. Remember, that was my third pillar. They want experiential learning. They want to be able to experience things and get feedback, right? Second problem was slowness. All right, well, we'll talk about that in a second because Umple was slow until about a year and a half ago. We solved that problem because we saw the survey and we said we got to deal with that. But other tools are also slow. And then drawing diagrams the way they want, interacting with other tools, complexity, and so on. So these are some of the things that we need in tools, but this feedback is critical. And here's a third slide from that research. This is the tools that were most cited in that particular body of research by students and professors. Okay, and Papyrus is the #1 tool out there being used. But people also extensively still use Argo UML, even though it hasn't been updated in quite a few years now. I remember actually going to an ICSI conference. I don't know what year it was, 1997, 1999. I think 1999 in Los Angeles, where Argo UML was unveiled, and it became the open source model for. But it hasn't been modified since then. Well, I think about 5 or 6 years ago now. A tool that's widely used in some areas, particularly South America, is Asta. And then there's a variety of Eclipse tools other than Papyrus that are being used. Magic Draw is a commercial tool that is used quite a bit. Star UML is really up there. But yes, there are quite a few people using Umple. We're getting a lot of use. And use, Martin Gogola's tool, it was also used quite a bit in this survey. Now, this isn't representative of this isn't a representative poll, because we happen to hit the universities that were using Use and were using Umple and so on. But nonetheless, for those users, it shows some things in red where there were clearly problems with feedback, like Argo UML is a little bit of feedback, but not nearly enough. Asta, the red things are the problems, and the green things are where the tool has a strength, right? So just looking at Umple for a second, it does have a strength in well, the inverse of complexity. People find it simple, but it also generates code along with some other tools. As of this time frame, we noticed it was slow, and we noticed it had some bugs. So we put a big push in 2018 to clean those out, and the tool can often run for months without crashes, and as you'll see, you can play around with it. It's on a super fast server now, so slowness shouldn't be an issue anymore. But other tool developers need to focus on their red things in that diagram. Okay, so before we move on, I'd like to just pause for a second and ask if there's any questions about where we are, and then ask you guys to click on this link, surveymonkey.ca/r/ and just look at that link. By the way, if you want these slides, you can go to you can find the slides. There's a number of ways of finding the slides. You can find them through the conference. The conference has a link to this page. This page, we've got slides for the tutorial. You click on that, it'll bring them up in your web browser. But in addition to that, if you bring them up in your web browser, and then you follow down, you can click on this link. But I will also put this link in the chat, so the survey link, just so that we have a response. I'd just like to get a sense. If I copy and paste this into the Zoom chat, if I can find it. Where is the Zoom chat? Sorry, too many windows open. Zoom chats. Chat. There we are. I see it now. All right. Good. All right, so there's the link to this survey. If you could just go there, it's only 3 questions. It should take you about 30 seconds. I'd just like to get a sense of the lay of the land, about who we've got here and what your backgrounds are, because it'll help me to tailor some aspects of this talk. And I can actually click on this link here. If I refresh my screen a couple of times, it should bring up the answers to this. Fortunately, one of the problems with SurveyMonkey is it's quick to answer surveys, but slow to respond to requests to get the data. But right now, we only have one answer. But I suspect that a couple of other people have responded since I clicked the button. So let me click the button one more time, and we'll see what people have said right now. All right, here we go again. Hopefully, we'll have a few more responses. If you haven't responded yet, keep looking at it. Okay, now we got 5 responses. Okay, so Papyrus, that's the #1 tool. Oh, no, it's not. Others, all right. Hand drawing on a whiteboard is up there. Enterprise Architect, Magic Draw, Star UML. Okay, nobody's actually used Umple, that's okay. At least nobody who'd responded by the time I refresh my screen. Then we have mostly professors. So, okay, that's expected. One industrial practitioner, excellent. And how much experience do you have generating code from models? Just a little, most of you. This response here was none at all. I do modeling, but I don't generate code. And then we have a lot. I mostly do this when modeling, which is excellent. I suspect that's the industrial practitioner, maybe working in automotive, but who knows? If you want to say. Okay. All right, let's go back to the presentation. And by the way, if you're interested in other modeling tools, there's some links here to some of the tools. These are updated lists recently. Umple's enlisted in both of those. So let's go. So here's a little history of Umple. Developed in itself, all right? So that's an interesting point. Obviously, the first version wasn't developed in itself. The first version was written in Umple, but we bootstrapped very fast. So this was 2007. We wrote our initial code generator, and then we rewrote it in Umple. So Umple is written in itself, which was a deliberate policy because we wanted to gain experience in use of this modeling tool. And so because Umple is written in itself, it is written using model-driven development, which I believe is not true for any other modeling tool. And I've always said, eat your own dog food, or, be reflexive. The first C compiler was written in assembly, but then it was rewritten in itself. And that is an important practical reality, that if you're developing development technology, eat your own dog food. So we did that early on, and it's been developed ever since then. And it's been developed mostly by students. You'll notice it says 95%. So 5% is well, probably 4% is me, 1% is other people in the open source community, and then the rest of it is 6 PhDs, 4 masters, 50 students in Capstone, which we'll talk about later on. This is Capstone projects, not just at the University of Ottawa, at universities throughout Canada, some in the United States, and a couple of other European universities as well. And 10 people I've hired as co-ops or interns, but still students, right? Now, one of the things that we ran into early on in the development of this technology was we ran into dependency hell, okay? We ran into problems relying on technology that was being rapidly modified at its own pace, but which also wasn't developed using model-driven technology itself. So we actually wrote our own parsing library, replacing Antler. So, and that's available free others to use if they want. It's a standalone library written in Umple that can be used for Umple purposes, but it can be compiled for any kind of parsing people want. And we also created our own generator. So we used Jet, which was an Eclipse library, Java emission templates. Still quite a few people use it if you look through GitHub, but we ourselves decided we needed to replace it because it was going defunct. It was deprecated, right? No longer supported, and we needed a tool that wouldn't happen to, because I want this to have a 25, 30 or more year lifespan, and it continues to grow. So we needed stability. And in a compiler, you do need stability because Umple code that compiled 10 years ago will still compile today, right? Yes, we've added new features, but the old code will still compile. And so we needed stability. That's one of the reasons why we rewrote our own stuff. So as it stands today, the compiler only relies on Umple and Java, and it will run anywhere from Java 8 to JVM 8 to JVM 14. In fact, 15. I tried it out on the latest JVM. It still works. Funding, just to acknowledge our contributors, came from the government of Canada through regular government funding, but also IBM contributed materially to development in the early days. And we also received a certain amount of travel funding for students who we met in person from Google and Facebook. So I need to acknowledge those people. In terms of usage today, before we get into it, it's mostly used by students in universities. So there's probably about a dozen universities that are using it quite extensively. I can tell that by just looking at the logs. But in fact, when I look at the logs, I see it being used around the world in every continent on a daily basis. So and this is the online version. So we get about 170,000 web visits a year. I think it's increased from about 150 in 2019 to about 180 in 2020. And about 3 million compilations per year of systems. So an Umple system runs through the compiler online, builds artifacts of some kind, which could be code that executes, but it could also be diagrams and so on. All right, website. So it's got its own domain, umple.org. You can go there anytime you want. Hosted on GitHub, and we'll be getting to this one, try.umple.org, extensively in a few minutes. All right, so you can click on any of those anytime you feel like it. All right, I'm going to talk about 3 different sets of features. Green coded class models, so attributes and associations. Red behavior models, focusing on state machines. And then separation of concerns. So all of these things are things I want to teach. So typically in an introduction to software engineering course, I would spend almost a quarter of it teaching about good modeling of the system structure. So that's the green stuff. And then, a lecture and a half to 2 lectures talking about behavior and state machines. And the students would do a lot of assignment work in both of these. So I'm gonna, as I walk through these aspects of Umple, I'm going to be, showing you Umple and showing you how I teach about these topics as well. But Umple also has a number of ways of doing separation of concerns. So you've probably all heard of aspects. So aspect-oriented development is a thing. And Umple has its own internal aspect mechanism that's native to it. So there's aspect J, which is a layer on top of Java, but Umple has aspects built in right into the language. But Umple also has traits and mix-ins. So mix-ins are available in some languages, traits in others. And then we've also got our own technology, which sort of layers on top of these for product lines called mixed sets. And I'll mention them briefly, but this is material we talk about for more advanced software engineering courses, where we want to say, you know what, you're building typically product lines. Very often you have, especially if you're building software for embedded devices, you're going to be generating a whole wide variety of versions of this. And you need to be able to do not classic conditional compilation with if-def statements. You need a much more sophisticated mechanism. And so these 3 separation of concerns together allow you to architect the system, divide it up in whatever way you want, but also to build different versions from the same models and the same code base. So I'll talk about those 3 things, but before that, a couple of additional slides, one on the overall philosophy and then on the tools, and we'll actually get you hands-on when I talk about the tools.
Tim, do you permit me a quick question?
Yes, by all means.
Thanks. So that sounds like product line engineering right there, and I would.
I have a PhD right now working on product line engineering and Umple.
Excellent. Please, whatever you have on that, I'd be very interested.
Yeah, it's a really important part of our sort of suite of things, and we want to teach that in 4th year and graduate courses as well, because it's very.
That's exactly why I'm asking.
We have industrial pull from that as well. As I said, there's a big bank in the United States that is using Umple, and they're interested in that as well.
Oh, I think I know exactly. Okay. Thank you.
All right. Okay. So these are the philosophies that we set out when we first started. So first of all, modeling is programming and vice versa. So basically, I said design abstractions is modeling, right? Well, guess what? While loops are design abstractions, a lot of the things which we now consider integral to programming are in fact abstractions of even lower level design. And so modeling basically just takes it one step further, or many steps further. And it doesn't mean that it has to be diagrams, but it can be. And so we made this perspective that, you know what, you can render these models both diagrammatically and textually, and we want either mode to be just as equally easy to use. Secondly, an Umple programmer should never need to edit generated code, right? So a lot of the code generators will expect you to, at least historically, to generate code and then edit it. So they would create partial code that you'd fill in gaps in. there was a term round trip engineering. I remember, 20, 25 years ago, there was Rational was based here in Ottawa, and which was subsequently merged into IBM. And they came and gave us a talk about how we should be teaching round trip engineering, which basically means you generate code, you modify the generated code, and then you reverse engineer that back into your model. Oh boy, what a nightmare. It doesn't actually work in practice. Companies have tried it. It can work a little bit, but it doesn't work in long range practice, and students hate it. So we said, you know what? You got to have one golden source, which is your program. And that doesn't mean that you're only programming in Umple. It means that other languages can be embedded inside Umple and are carried by the Umple files. So you'll see that in a few minutes. And so the Umple compiler, the 3 and 4 are jewels of each other, can accept and generate code that does nothing but UML abstractions. So you've got a UML state machine, no problem. Represented in Umple, pure UML. Same with class diagrams. We also do a few other pieces of UML, but we don't do the entirety of UML, but those two things. On the other hand, you could also, the extreme opposite, simply use Umple as a carrier for programming languages. So Umple can support internal embedding of Java, PHP, C++, and Ruby. Now, we've had people say you really should be doing Python, and we hope we will. But right now, those are the 4, okay? And so if I put a Java program inside, and you'll see that in a minute, an Umple file and compile it through the Umple compiler, it'll just spit out as if it was pure Java. Right? So the point is you can blend programming languages. And this allows you to use Umple's separation of concerns mechanisms and product line mechanisms if you wanted to entirely with Java. And so you can teach a product line course with Umple without doing any modeling if that's what you wanted. And indeed, you can also say, well, we're going to have alternative languages. You can target a system to both Java and C++, and you just simply tag block of code as Java, or tag a different block of code for the same method as C++, and depending on which one you generate, it will generate the right thing. So P5 then says you can turn existing code into Umple. I had a PhD on this. It works. You can take a Java program and you can amplify it, which is a reverse engineering. It finds the class diagram, turns it into Umple, and reduces the volume of code substantially as a result. Because essentially what happens when you generate class diagram code from Umple is it generates a heck of a lot of boilerplate that you're going to have to, you can get rid of once you've amplified your code base. P6 says that we want to make this minimally invasive. You can adopt Umple without having to go into heavy duty tools and change your methodology. You can go along with the same old methodology you want. You can use Umple very lightweight. You can have a 99% pure Java project, but build a state machine in Umple and link it in the normal kind of way, right? Same thing with other languages that are supported. So it can be used as an add-on to existing code if you wanted to. And you can then incrementally extend your usage of Umple if you felt like that. And the idea here was we wanted to make sure that people didn't think that, oh, well, Umple's not widely used in industry yet, therefore we shouldn't be teaching it. Well, you can use it to teach state machines and embed them into other code that people are developing. And we know that that's being done in industry. People are using Umple purely for pieces of systems where they want to be able to do something extra specially well with a model. And then we can create diagrammatically and textually, right? So you can do both, and for class diagrams at least, you can edit the diagram and it'll update the text and vice versa. And it goes beyond UML. So people have said, well, you don't follow UML too precisely. No, we don't. We implement a subset of UML2, almost all of state machines and class diagrams, a very small subset of OCL, object constraint language, and that's it. But we do stuff beyond that. So the product line stuff we talked about, and aspects, for example, and embedding multi-language code and so on. All right. Any more questions before we go on? All right, I will move on. I'm just checking my time. Okay, good. So if you want to follow on, I'm going to make this hands-on for those who want to do that. And so minimally, to follow along, you just need a web browser. It would help if you had a second screen so that you can watch the talk at the same time as you're doing stuff. If you do, or if you can split your screen, that's great. But any web browser will do. We tested in all the major web browsers. Google Chrome, Safari, Firefox in particular. I have to admit that I haven't tested it recently in the latest version of Edge. That's because I use Mac and Linux and not Windows, but other people have, so it should be okay there. Now, for a richer experience, and I'm going to show you this, if you have a laptop or desktop or whatever, but not a tablet that has a JDK in it, Java Development Kit, any version from 8 to 14, then you can compile on the command line. I'll show you how to do that. And furthermore, if you have Mac, it will work on Windows, but if you have Mac or Linux, it's just a little bit faster. There's a few specializations that we've put in. We haven't yet put into Windows. We will, but right now it works just a little bit better, a little bit slicker on Mac and Linux. Okay. And then we also have a Docker image. And this is being used by some people in industry. Essentially, you get the web browser experience with running locally on your local machine, right? So if you're using a web browser to the public modeling site, try.umple.org, then you're sharing resources with everybody else using that site. But if you want to run it locally on your local laptop or whatever, you can run it in Docker, and you get exactly the same experience. All right, but then I can't track you. Whereas in the public site, I can count how many people are using it. But we do maintain privacy, and we do have a privacy page that says we're not going to look at your stuff either way. All right. Now we have an extensive user manual, and it's all sort of dynamic. So I'm going to actually jump through right away to this page, helloworld.umple.org, which will take us into one of the pages in the user manual. And I will zoom in a little bit to make the text a little bit bigger. Okay, so this is the user manual. You can search for things. You can actually translate it. It works quite well because I do have people in China using it. If you want the user manual as a printed document, you can click on combined version and print out the resulting PDF. About 350 pages of PDF if you want it. But most people won't want to do that. Ironically, it was people in China who said, we like to print big documents still. So, okay, no problem. Anyway, let's take a look at a couple of other features of this manual. One of them is that we have examples of Umple code. And this is the first example. It looks exactly like Java. And that's just to prove the point that you can embed Java code directly inside an Umple file and compile it in Umple. And all of these examples throughout the entire manual, and there are hundreds and hundreds of them, you can load them into the live system. So I click on that link that says load, and it will load up Umple Online. This is at the website cruise.umple.org, which is a very powerful server farm that is run by Compute Canada. I used to run it at the University of Ottawa, but time came to renew the machine, and Compute Canada, I have to acknowledge them, have given me access to their server farm. So Umple Online now running in there. And I happen to know that this particular instance is running at the University of Victoria right now in Western Canada. So this is Umple Online. And what you see here is that example with the hello world loaded up into a single class diagram with a single class. There's nothing much there, right? But let me show you a couple of things. I think I'm going to zoom back out just so that we can see that. Notice it's a responsive interface. So it will adapt to the size of your screen as it should. Let's just generate the code in Java. And so we see here in Java that essentially when we do this, it generates a little bit of debugging stuff that you don't need. But the core thing that we have is this main, right? This main system.out.println hello world. This extra stuff is simply, as I said, for dynamic debugging of the code, which is not that relevant in this particular example, but is extremely useful for subsequent large examples. Okay, so this is hello world, and it doesn't have anything in it. It's UML diagram. I can edit it. If I wanted to actually add an attribute, I can do that. And so I typed A, and it said, well, by default, we're going to assume it's a string, and now I have an attribute A in here, right? And if I wanted to as well, I can create another class, click, and then create an association between them. Click. Oops, sorry, I used the wrong button to click. I want to click there, and then I want to go click. Oops, sorry, association, and then click. All right, and I drag that out a little bit. You can edit this diagram and move it around. I can edit the locations of these endpoints. So you can do the kind of normal. So unfortunately, the mouse button is broken on my computer, so that's why I'm having trouble with clicking sometimes. But now I've made an association, a UML association, and down here we see the notation for the association that is written textually. It's written an association. It's created this class called new class, and it's created an association between the hello world class and new class, defaulted to many to many. I don't want it to be many to many, no problem. I can go in here, I can say many to one, all right? And there's my thing, and I want to call this, I want to double click on this and say, and call it, stuff. Okay, no problem, class stuff, right? It renamed the association and it renamed the class, right? So this is this diagram textuality, and we're going to see this onwards. And the reason why this is important in education is that, well, first of all, when the diagrams get complicated, students, they understand the model better when it's diagram form. But at the same time, they're used to code, and they see this and they say, oh, okay, that's just looks like Java code. It's got a little bit of extra stuff in it. No pun intended. Now, like any compiler, we can have multiple files. So I can click on this plus symbol here to add additional files to my system if I wanted to. I can generate many things other than Java. So for example, what's the API of this? If I want to call methods in it, generate that. And it will say, okay, this is the API. We've got these things we can call get stuff, get A, because we had two attributes, right? Set A and set stuff, and so on, right? So I'm not going to belabor that, but you get documentation generated automatically. And if I put in here stuff and I said something like, whatever, and here by A, I said foo bar, to use the classic computer. Whoops, that's going to give me a compile error. By the way, warning on line 12, attribute or association syntax could not be processed. Right? And it says this is an example of, you want to look this up in the user manual to find out what's wrong with it? Well, click on that link. But anyway, didn't intentionally do that. It just tells me I'm going to fix that syntax error. And now I've got foo bar. I'm going to generate the Java again, and we'll see that where did that foo bar show up? Foo. Okay, there's in the Umple code, and here it is in the description of the method down here for getting it, right? And that will also then show up in my Java doc. And so essentially you have self-documenting, because whatever you put in as comments is going to show up in your documentation of the API that you're building with this class, right? And I can't tell you everything there is about Umple because there isn't time in a 3-hour tutorial. But all of these things are things that we've put in because end users want them, and because it teaches students to document. Because this documentation is not wasted; it shows up in the Java doc style output, and so on. And indeed, let me just click on one more thing. This is another layout of the same diagram. There's multiple diagram layouts available. If I hover over this thing here, the foo bar shows up in the diagram as well, right? So the diagrams are documented the same way as the code is. We've got to re-indent code to make things look prettier if people find it a mess. We've got infinite undo, which will undo either the diagram edits or the code edits. And very nice. Available. All of these things are a lot of the time students have raised issues. We fix them. Let's take a look at some of the other things you can generate from this. You can generate alloy, formal method, and NUSMV, formal method, mostly for state machines. In fact, you're going to get a kind of useless model because it's not a state machine. But you can generate eCore, which is used to convert this into a usage in an Eclipse-based tool. And Papyrus, you can output to that. YAML class diagram. Well, let's do that. Generate it, and we'll see. Oh, that's interesting. We have a problem with YAML. It might be at the YAML end and not at my end. Okay, I'll have to look into that one. Maybe a dependency problem with YAML, but YAML is another design thing. Feature diagrams, you'd have to do more sophisticated stuff. But entity relationship diagram, you're doing databases. Well, you know what? Let's do entity relationship diagrams for the same thing, right? A lot of these things are relevant to state machines. You want to make an SQL table set for this to teach databases. You can get that as well, and so on. I'm not going to go into all the generation targets, but we've got quite a lot of things. A use model. Okay, so this is another. This is Martin Gurgola's tool. So this is the use model of the same thing. All right, and I think that's enough for now there. We're going to come back to this tool in a little while, but I wanted to show you the Hello World model first. Any questions? No. Okay, let's move on there.
Question.
Yes, question.
So I think you said you can import import a existing Java code base, and it will automatically create these UML diagrams, correct?
That is a tool that was developed by a PhD student called the Umplificator. Okay. So yes, there is a tool called the Umplificator that will do reverse engineering. It uses a rule base and will bring in Umple. Yes, it will bring in Java and produce an Umple equivalent Umple code base.
Very good. And the follow-up question is that in that case, can it detect the design patterns that are used in that code base?
To a limited extent, but that would need more research to be more complete.
Gotcha.
It does a few basic things, and we'd have to extend the rule base for that. And as you can imagine, the rule base would be quite extensive even for basic cases.
Mm-hmm.
All right. So one of the things we talked about, we've seen attributes, associations. We've seen, I guess we haven't seen the class hierarchy yet. We'll get to that in just a second. But I've shown you most of these things where I added an attribute and I changed the multiplicity. I didn't show you the undo, but essentially you can undo anything you want. Let's go on to the next slide here. So if you want to download stuff, there is a link, dl.umple.org. It'll take you through to this page. And this page gives you a number of options for downloading. So one of them is, of course, the command line compiler, which we'll get to, and then of course it also will talk about the Docker and a number of other ways of downloading. But what I'm going to do now is I'm going to download the Umple compiler. You have the official release, which we release every few months, but this is the build that it comes out of our continuous integration server, and we haven't done any builds for a couple of weeks now. It's been a little bit of a hiatus, but some periods of time we have multiple updates this per day, and each of them has to pass about 6,000 tests, including recompiling the entire Umple compiler in itself. We'll get to that later on. That's part of my teaching in advanced courses, how to do that right. So if you want to download the Umple compiler, you just click on that link, and it comes down to your downloads folder in whatever operating system you're using. And I'm just going to close this because I don't need this one. But if I go to here, and I should see ls star.jar should give me umple.jar. So there it is. It's in my temp folder, but you can put it wherever you want. To make all the examples work, you need to create if you're using Windows or Mac, create a TMP temp in your own home directory. and throw the umple.jar downloaded there. If you do that, then all the examples that follow on the command line will work. All right. So I just wanted to sort of illustrate that point. All right. Another thing you might want to do is this. So this is a script, a Unix style script to simply alias this java-jar tilde temp / umple.jar to umple. So umple then becomes the name of the compiler and you can use it like a program. So I had already done that. But if you do that, then you can simply compile things using that keyword directly. It just makes things a little bit simpler for students. So I walk them through that, at the beginning of labs or in the class. And once you've got that, and you've got that umple compiler downloaded, from that point on, you can just use umple just like a C compiler, right? Just compile stuff and it'll work. All right. So let us actually try a couple of things. Let's actually download something. So what I'm going to do is I'm going to go back to the user manual, which should be here. I'm going to go to the Hello World examples, and I'm going to download the second example. So this is another slightly more sophisticated umple program that's got persons, students, mentors, an association. Notice the keyword association there. And then a main program that actually can execute to run this thing. Let's load it into Umple Online first. And it will draw the diagram for us. And then what I'm going to do is I'm going to compile this and run it. Okay, it's got a main program in it. It should run. Well, if you follow the directions so far and you did that alias and you downloaded the compiler, and you're on Mac or Linux, as I said, it's a little bit more for Windows. You're going to have to download the compiler and then type that Java and so on. But there's a key in Umple Online, Control O, that says shell command to compile compile this on command line was copied to the clipboard. Flip back over here, paste, creates a file and compiles it. All in one step. So it's simply Control O to output this thing, and it's compiled. It says here compiling using this compiler, processed, main method found, run Java person. Okay, so there's a main method in the person class. We saw that right here. Okay, there's the main method. And then I'm going to type Java person, click return, and it says the mentor of Tom the student is Nick the mentor, and the students of Nick the mentor are, and there's got brackets list Tom the person. And that's coming from running this main method, right? And it's following links in these associations. So what we did was we created a new mentor, we created a new student, then we called set mentor, which is operating on this association on the student. S is the student, dot set mentor. Okay, it's 0 or 1, so it's not add, it's not a plural, it's a singular. M, which was this this mentor, Nick the mentor, and then we're simply doing two outputs. This is standard Java, right? And so what this is intended to illustrate is at the very basic level that we can execute Umple programs and they can operate on UML features like associations. And later on, we'll see many, many other things they can operate on as well. All right. So we're going to come back and we're going to do more of those kinds of examples. There's been a lot of demand from students. And as I said, experiential learning. They want to be able to do these things instantly. They want instant feedback. And yeah, people say, well, instant feedback, it dilutes the brain. Well, I'm sorry, it also helps people to learn faster, right? So this ability to jump stuff into the command line and run it right away helps them to debug their programs. Now, let me just say I made some kind of mistake on this. And I said something like set mentor T, all right? Well, this is invalid Java. Whoops, where's my code? Oops. I'm having a hard time clicking on that because of my mouse not behaving. I'm just going to refresh the screen, and now I should work. Set mentor T. All right. All right. Now, there's nothing wrong with the Umple. I'm not getting any compile errors because Umple Online will only compile the Umple. It says the model is fine. There's a problem in the Java, right? So what happens? Well, now, if I do this Control O, take it to a terminal and paste, I'm now going to get a Java compile error, right? Okay. And this says that we have an error in test.ump line 36. And if I go back over here, it's here it is. It's line 30. Well, it's round about here. It's off by 1. But it basically points you to the Umple location of the Java error in your Umple code. It's not pointing you to generated code. It's pointing you to the original Umple code. And that was a very important thing that we had to put into the system because people said, if the philosophy is you edit the original Umple, and if you got embedded Java in the Umple, then when you debug it, it better debug in the Umple original. And so that's what happens. And you just saw that in that example. Questions? So again, a lot of the little user experience things we've put into Umple are based on experience in using this for 12 years with students, and a little bit of feedback from industry, but mostly from students. So this is the example in case we had trouble with the internet, whatever, and if people want to download the slide, they can see it. That's just what we looked at. All right. So I'm going to just talk a little bit more about some of the things you can look at in Umple Online. If we go back to our example here, there's a number of options for laying out the diagram. I already showed you this G button for changing the layout to, this is using GraphViz, and this is using Umple's native layout, right? So they're two different layouts, and GraphViz will often do an automatic instant correct job in most cases. And so, we encourage people to play around with either layout they want. If I click on it, in either case, if I click, it'll highlight the class. So this is highlighting class student. Notice on the left-hand side, it highlights the text. This is, if you click there, it'll highlight class mentor. All right. But we do have methods. Methods not being shown right now. Click on show methods. It'll show the main method, right? You don't have to show methods in class diagrams. In fact, I don't have to show attributes. I can take them out, right? And often you just want to show the class relationships just by themselves, right? And sometimes students don't want to see the diagram. Well, you can get rid of that. Sometimes they don't want to, well, if I do that, I get nothing. I got to at least see one or the other, but you can bring them back. And you can also, if you wanted to, change the relevant sizes of these things, so it's responsive to size. So whichever one I want to focus on. And we have control keys for a lot of these things. So I want to get rid of the diagram. I can just type Control D to bring it back. Right? Little things like that, students have found really useful. Now, what if a student wants to submit an assignment to a professor? Well, no problem. Save as URL. And now what I get is I get up here a URL, and it's encrypted. It says 2011-09, which is the date, which kind of gives a hint as to the date you first created this model. And then a bunch of characters in base 36. And there's, well, trillions of possibilities. It's a bit like short links in Google or Bitly or something like that, right? So nobody's going to be able to find your model unless they can try trillions of times to guess it. But essentially, this is a public link, and you can give it to other people to collaborate if you wanted to. And you can hand it into your professor, and the professor can then, or the teaching assistant can then look at this model and do anything in Umple Online with it. So we've had this facility available for quite a few years, but we went one step further, and then the latest feature available is tasks at the bottom here. So what I can do as a professor now teaching is I can say, well, I want to give an assignment in this. So I'm going to click on create a task. And this task is going to be, hello whoops, hello world, hello CSEET. Okay, so, and then the requester name is Tim. It's actually optional. Task instructions are to, I don't know, add a name to students. Actually, we already have names because it's inherited from person. So let's just say add a an address. By the way, this is Markdown. So I can tell any kind of Markdown I want. You know what Markdown is? The language used for editing Wikipedia and GitHub comments and so on. So I can actually create quite extensive. If I want to make this bigger, I can. I can make this, come on, make this bigger, and I can write Markdown there for the instructions. So I'm just going to say here something like, in fact, I'm going to say add to students address and phone number. Now, if this was a scientific experiment and I was running this for a bunch of people who were going to participate in a study, I could click on is experiment here. And then if I have ethics approval and all the rest of the jazz, I could then look at the results and do some comparisons and so on. But we're not going to go there today. We're just going to do this as if it was a student assignment. There's an additional URL I could put in that if I chose that option, I would be able to, once the student submits an assignment, it will send it off to an educational management tool like Brightspace or Moodle or something like that. So you can hook it up to those tools for automatic adding into those environments. I can also put it into SurveyMonkey, so it will allow me to gather the data in that environment as well. Anyway, I'm going to leave that off for now. This is the very basic case. I'm going to say submit task. All right. And now what you see is I'm still the professor here, but this is now, and I can still continue to edit this thing. But if I were to go and click on copy participant URL, and then I'm going to go into the chat here. All right. You guys should be able to, I think there may be an HTTPS missing off that. HTTPS : / this thing. Okay, there we go. If you click on that, it should take you now as a student doing this work. All right. So I invite you to do that. And well, we can always add an address here like this. Make it a string if you want, but I could also be more sophisticated and I could make it into a separate class, and I can add a phone number if I wanted to here. And by default, it's going to be a string, but I don't like that. I want it to be an integer, no problem. Notice it's using UML notation here, so the type is after a colon. But I could also, if I wanted to, set it up as a separate class. Whatever you feel like. Is anybody doing this? If you are doing this, yes. Okay, so I'm going to wait a second before I, tell me when you submitted it, okay? The submit button's right here. Submit response, right? So we can open the instructions in a new tab. So if they were extensive, the student could see them there. And unfortunately, I've got this Zoom thing, so I'm going to have to move it out of the way. And hopefully it won't screw up. Moving Zoom out of the way won't screw things up too much. Okay, we're back here to okay, open instructions. I can also hide them and re-show them if I wanted to, right in this thing. And I can cancel if I don't want to do it. But at some point I can submit my response. Submit response, successfully submitted task, close. Now the student still sees their work. And the student can still access it using this URL if they want. But guess what? It's read-only now. So they submitted their assignment and they can't fiddle with it. So it's submitted, it's final, right? So we might need to add a feature to allow reopening or resubmission or something like that. But if they wanted to resubmit it, they could simply copy and paste, make a new submission, I suppose. But anyway, there we have that submitted. Now, one of the things I did say was that we don't know who submitted it because it's anonymous. So we tell students, in code, put your name and student number and top level comment. I forgot to do that. So there's going to be an anonymous submission. So unless I had filled in that Moodle URL or that Brightspace URL, which would take you into the tool and whatever, it's going to be an anonymous submission, which is deliberate because we want people to be able to use this for experiments where we exactly want it to be anonymous. So anyway, as it stands right now, let's take a look. Let's go back to the professor version of this, which is here. Oops, where was this? One of these tabs was the professor version. Too many windows open. Which one was it? One of these. This is the one. Okay. So this is now as the professor. So what I can do here now is I can go down here into tasks and request all directories as a zip under this task. So if they didn't happen to go into Brightspace or Moodle, then I can just download them all this way. And it says download zip file from here. And if I gave this URL, which is a different one, again, confidential, but I can find that. And if I go back to my terminal now, I should see in here, oh, way too much stuff. ls star.zip, oops, star.zip, sorry. I should see umplefiles.zip. That's the one. So I'm going to just make a directory assignment answers, move umple files.zip to assignment answers, cd, go there, unzip umple files.zip, and we have, oh wow, we got quite a few of them. Very, very good. Lots of people did this. So I can open any of those ones and look at them. Notice, well, actually, hang on a second. We got multiple. So what do we got here? We've got 1U9189. We've got, anyway, we got a bunch of them. So basically, we've got, it's the ones that are untitled.ump that we care about. I should say ls star dot untitled star. Sorry, yeah. Yes. Back there. Oh no, okay, it's correct. It's these ones. Yeah, so they're individual directories. It unzipped them, but they're in each individual directory. So a total of there was a total of 7 people. So if I go to one of these things, go to this one, and that might be mine. Let's go to, well, whatever. We can grab this file, open. Actually, I'm going to open it in BB-edit, person.ump, and this is one of them. It's probably the one that I submitted. Oh, we have student is a person. Anyway, this is the file that was one of the files that was submitted anyway. But if they've got the names on them correctly, then we would end up having being able to mark them. So this feature only went live at the end of September, and we started to use it with a few classes so far. Questions before we go on?
I have a question. So how long is this public URL available? Let's say I submitted my homework. How long will you retain this?
Good question. The general policy is that these links stay around for a year after their last edit. Okay. I have a reaper that will reap any of these each of them is a directory, and it will reap any directory whose internal files have not been edited in a year. So that goes for all of the models that are live on Umple. If you want to use the Docker image and set it up locally at your own institution, you get exactly the same feature set, but then you can make your own decision and you can keep it running for however long you want. So that's the current policy. That if you didn't name it, if you didn't say save this URL, then there's a hidden temp file that stays around for a month. So it's a year if you name it and a month if you don't, as it currently stands.
Thank you.
Right. Now, our intent is to instrument Papyrus to have some of the same capabilities, because I want to do a comparison, experimental comparison between Papyrus modeling and Umple modeling, so that we have a couple of PhD students, one here and one in Iceland, that are looking at that kind of idea of being able to instrument tools, multiple tools the same way, so that we can do those kinds of comparisons. I've shown you lots of features in Umple Online. I can't show you all of them. There's not enough time, but let's move on a little bit. Right, I'm going to go back to the user manual, because there's a couple of things that are relatively important in the manual. So this is the manual again. I want to show you down the end here. One of them is these errors and warnings pages. I alluded to them, but every single error message or warning message has a manual page associated with it that explains what could have gone wrong, and it gives an example of it going wrong and an example of it going right. So we try to get the students to say, well, okay, well, you got error message 004 invalid multiplicity. What does invalid multiplicity really mean? Well, it means you didn't use one of these patterns. And for example, 0.1.2y, click on that link in Umple Online, and it will pop up this message. And if I click on more information 5, it'll take me right back to the manual in the same place, right? So every message brings you back to a manual page. How do I solve that? Well, here's the, actually this is telling me about, oh, that's interesting. Took me to the different manual page. Okay, that wasn't intentional. Association end is not a class or interface. Okay, interesting. It's seeing that as, all right, okay, that needs to be fixed, because it's finding a different problem with the same line. All right, note to self. Still, it will lead the student to solve the problem because the syntax is wrong. Anyway, but that needs to be fixed. Back to the manual again. If you want to understand the grammar of Umple, there is the information about that. I'm going to hide this for a second. Down here, where is it? Grammar to define Umple. Right, there's 2 pages of that. One is the notation, and the other is the grammar itself. So this page is actually generated from a DSL, a domain-specific language, which represents the Umple language in its own parser. I said Umple parses itself. So this is actually the file that came from GitHub directly here, right? Click on that link and you can go back to the GitHub and see the actual source of this file, which gives you this grammar. So a program is either a use program or an Umple program. Now that's interesting, because we can actually parse use language, subset at least, with the Umple compiler to convert it into Umple. So that's why it says it's a use program or an Umple program. And then Umple program is either a comment or a directive set and repeat it, right? Excuse me. Drink a bit of water here. And these are the directives. So at the top level, you've got things like generate, what language you want to generate, distribute. There's a whole master student did work on distributing multiple components to multiple hardware machines or virtual machines. And so you can write an Umple program that will build multiple executables, essentially, and that's what that keyword does. And there's a whole bunch of others, use statements, namespace, but of key is entity, which will then take you into the list of entities, which can be things like classes and traits and so on. So Umple is, there's a lot of stuff in Umple, but the students don't need to see all this stuff unless they really want to. And if they really want to, they can explore it because it's all documented. And as I said, documented in a live manner. Errors and warnings. Oh yes, and if anybody sees an error, they can just simply edit any page on GitHub, and it will take you to, here's the page on GitHub. This is the link. You can edit it and do a pull request to fix that fix that, that grammar page. Okay, let's go back. All right, excuse me. So as I said, Umple supports UML, and one of the key things of UML in classes is attributes, and attributes are more sophisticated than variables. They're more sophisticated than instance variables or fields, as you would find in Java. Why? Well, first of all, we get methods generated, get and set methods. And the variable itself is private, which is following good design practice. Okay, I always used to teach that, and this just generates the code automatically. Well, that's not a new thing because you get that in various kinds of languages like C#, for example. That's sort of being built into languages like that. But you can also stereotype these attributes. So UML has this notion of stereotypes, which are little tags in angle brackets that you can put on classes and other features in UML to say, treat them in a special way. So in Umple, we have a whole set of stereotypes, and I don't have time to go into them today, but you can look them up in the manual, which affect code generation. And so the code generator is written to look for stereotypes and change the way the code is in particular kinds of ways, such as making the attribute or the whole class immutable, for example, or the singleton pattern is a classic example. Singleton stereotype, it will generate the standard gang of 4 singleton pattern for that class. Another thing you can do with attributes is you can apply aspects to them. So I said aspects is natively built into the language. So you want to teach aspect-oriented programming, no problem. We have point cuts and stuff like that that's built into the language, and they apply to attributes and associations and state machines and all the other stuff. But that's a more advanced topic. I would typically teach that in a more advanced course. But what's nice about it is that unlike, say, aspect J, you can apply it to the modeling constructs, not just the below-level programming constructs. And then constraints. So OCL is the UML constraint language. We don't do all of OCL. We do a small subset of it right now. But nonetheless, you can teach that concept of putting in invariants in classes and preconditions and postconditions in methods. And the constraints operate on attributes as well as on other things. So generalization is a key feature in all of object-oriented programming, and it turns out that each programming language uses a different syntax for it. So we wanted this to be language agnostic or language inclusive. So it should work with Java and C++, and you should be able to embed code in those languages right in the language. And that posed a problem for us, because if we use the Java syntax, then it kind of would be a problem for C++. So we said we're going to use our own syntax for generalization. And following on from the way I've always taught, the ISA rule, it's simply ISA. So rectangle ISA shape. And that's also used for implementing interfaces and traits as well, right? It turns out to be a design choice that solves several problems at once. But I won't go into this in depth, except that there is a good example online. And so I talk extensively about this particular example, where I have two-dimensional shape. This actually came out of my book, my 2004 book, published by McGraw-Hill. So I talk about all the various issues associated with, well, abstract methods and abstract classes and inheritance and overriding and polymorphism and stuff using this example. And an assignment that I can give to students is to go into Umple Online, and here we have examples, class diagrams and 2D shapes. So this is that example without the methods. And I say, okay, go code those methods. They're not that difficult. And add them to this model, right? You want to look at it in a different way. There it is in a different way, but you can add the methods and try and get that to work. And it really deepens their understanding of polymorphism and overriding and stuff like that. As I mentioned, we can have user-written methods. You saw that for the main method, but you can write any methods you want. And in fact, during amplification, you just bring in the entire body of methods, and then you gradually get rid of ones that get generated automatically. That's what the amplificator does. And you can have different bodies in different languages. So if we go back to the user manual here, and we click on methods here, and now we've got alternative languages, it shows you the syntax. So method 1 in Java is this, and in PHP is that. All right. And if you now say generate PHP, I'm going to get a return of 0 from this method. I mean, that's not consistent, but it's to show it by example. So I can, any place in the example where I have a body of code that's native code, I can tag it with a language. Otherwise, by default, it assumes that you're using whatever language your target generated language is. So I don't have to say Java. It will assume Java if I'm generating Java. Any questions?
I was just wondering how static attributes are defined, static methods and static attributes.
Right, that's a very good question. 2 answers to that. First answer is, I've always taught, avoid static attributes like the plague unless you have a very good reason with a particular design pattern. So there are a couple of design patterns where static attributes are useful. And I say, such as the singleton pattern, and it will, when you use the stereotype singleton, it will generate a static attribute in that case. Static methods, I encourage people, again, not to use, except in certain patterns. So essentially, you don't declare them, you just have to declare a pattern if you want these things. And that's to enforce good design practice. So basically, that's the design decision, and we've built large systems, hundreds of thousands of lines of code without using any static methods or attributes except the ones that the patterns dictate.
Okay, thank you.
Another question.
Yes.
You show how to directly access, for example, the GitHub pages. Is this also possible to present a GitHub page as a source? Because then students might be able to diff their differences between what they have changed.
Yeah, that's actually a good idea. Of course, there are examples of Umple systems on GitHub, right now you can't sort of commit your code to GitHub directly from Umple Online, but it might be something that would be nice to be able to add. So feel free to raise it as an issue, but I think it's something, I think that's a great idea. Yeah, directly connect to a GitHub repo and show it in Umple Online. That would be fantastic. Currently, you just, I mean, let me just go for a second to code.umple.org, which brings you into the GitHub hosting. And this is Umple itself in GitHub, obviously open source. This shows that it's compiling. Compiler is compiling in Linux, OS X, and Windows. And if I go to, there's a bunch of subsystems, right? So we have subsystems here for different generators, for Eclipse and so on. But the most important things are going to be down in cruise.umple. So that should be here. cruise.umple/source. And this now, notice the .ump files, right? So this is this is the Umple file in itself. Actually jumping through to the end of the tutorial, but that's okay. So if I, for example, want to see what the Alloy meta model is and generating Alloy, I can click on this and this will show me what this looks like. Actually, this looks like just code, not much model in there, but it does show you that you can have a lot of code in there. Let's click on some of the other, something else. One thing I could do is I can go to master. Okay, so the top level file is master.ump. And first of all, this says ignore certain warnings. And then it says these are the Umple files that are composed together to build this. And so I can look at any of those and I can follow links. And while we're at it, I might as well do this. There's a architecture, oops, I had it, architecture.umple.org. will bring you through to the wiki page on the architect. There's lots of wiki pages. You can see the links down here. But this is the top level architectural documentation for Umple. And this will point you to certain files, like, for example, the master we just looked at. But it will also take you through to this page, which is the Umple compiler generates its own diagram. So this is Umple compiler that's generated itself, generated a diagram of itself, right? And so, for example, here I have the class state, can I zoom in on that? Well, it's a limit of zoom in. It's a little bit of a big diagram, so it tries to fit it all in a reasonable amount of time. But it'll tell you the files. You look down there, it shows you the files where this class is defined, and this class state is defined in 5 classes. How could that be, you might say? Well, it's defined in those 5 places because of mixins. So we build this in 5 places, in class state machine, in class, we have a feature called for traces, we have a feature for diagrams. And I can also click through onto that, and it will take me to the API of this class, so that if I'm developing Umple as an Umple programmer, it will allow me to see the methods that I can call on it that are coming out of the generated code or the methods that I put in. So this is what the capstone students use when they're modifying Umple. You gave me a segue, so I thought I'd show you that. Flipping back, unless there's any other questions. Referential integrity is a concept in databases, right? So if you have students have mentors, the mentors know about the students, and the students know about the mentors, and they kept up to date with respect to each other in their SQL tables, right? But it's the same thing in associations in Umple. So I can find my mentor from my students and my students from my mentors. And so the API and the code that's generated will automatically maintain in-memory referential integrity. And this is an important point, because a lot of pain goes into programming code, whether it be in Java or C++ or any other object-oriented language, if you want to do this in memory. Most people rely on doing this in a database, and they're bringing it into memory. But if you want to do it strictly in memory, which you do in many kinds of real-time systems, then, well, Umple provides that for you. And students like that, and it cuts a ton of boilerplate code that you'd have to write in associations. So here is some teaching material that I used. This actually was material I produced back in 2001 originally when I was writing my book, but it's still relevant today. So I teach students about, well, different kinds of associations, and then I actually build them in Umple, and we play around with the code that gets generated, and we generate examples. So we already saw the mentor-student, well, the company employees, and other kind of one-to-many association, right? And you can have labels and so on. And I talk about the cases that are here, and we can demonstrate in practice, experientially, that, yeah, I can't make the employee work for more than one company. And yeah, there might be moonlighting, but this company is the company that I'm building the system for, right? So even though the employee's moonlighting somewhere else, I'm not managing their employment in that company. So that's why this multiplicity is 1. And once the student sees the code and they actually execute it, they understand why that would be the case. And we did a study back about 10 years ago now, after just 3 or 4 years of Umple being out, that showed that students did much, much better in exams building models once they had experience using Umple. Many to many, well, that becomes a challenge in databases. You typically have a class in the middle. And indeed, if you generate SQL from Umple, you will get that. But in memory representation, you don't need the intervening table. You just have, it will manage properly the representation no matter what the multiplicity, as long as the upper bound is an asterisk. And indeed, I have these slides, and I can click on open in Umple, and it doesn't actually bring it from the user manual. It brings it from a representation that is that is encoded in notice it says #20, #7b, and so on. So it actually brings it in the URL, carrying the model in the URL string itself, meaning that people can distribute that PDF file or that book page anywhere they want, and they get a brand new model from that every time they click on that link. But this will allow you to play around with this example right from your PowerPoint, which can be quite useful. Then one-to-one. I talk about one-to-one as being a big challenge. And the code generation for one-to-one is quite different, because essentially, I got to have the same number of companies as boards of directors, and I got to build them at the same time in order to make the constraint be true all the time. And it's really important for students to understand that if they're going to build proper models, because they very often make mistakes and they put in one-to-one when it shouldn't be. And so again, I have an open in Umple link, and we play around with it and we see the consequences of really why it's important to be very wary of one-to-one. That's often a sign of a mistake. Any questions before we go on?
It's really cool for teaching. I really congratulate you. It's fantastic.
Super. And I'm not going to go into all of the UML because there's lots, but unidirectional. Why do you want bidirectional navigation? Why do you want unidirectional navigation? Well, it depends on a number of features. It's unidirectional if you want this day class to be by itself and reusable, so it's navigable. You can navigate to notes. Sorry, I got it backwards. The note class is reusable. The note class is reusable, doesn't know about days, but day knows about notes. So note is a reusable class. And but I can still put it in an association to between days and notes. But the default in Umple is bidirectional, because that just gives you a lot richer of an API. You get half the API if you make it unidirectional. But that's okay. In many cases, that's the design you want. And of course, you can easily change it. So if you were coding this up in Java and you needed to make that change, it would require a day's coding. Whereas in Umple, you just change the multiplicity in one place and poof, immediately your API is changed. It's consistent where possible, but you've now added the API in the note class that knows about days. So I think I'm not going to open that, but it's available there. Here's another example, association classes. So I talked about many-to-many, and quite often you do want a class in the middle. So here we have student and course section, and we want to know the grade of a particular student in a particular course section. So in teaching about this, I have to teach about two alternative models. One model is this model, which is the case where we have this class injected right in the middle. And it's very similar to this model, but UML has one extra piece of semantics for association classes. And that is that in this model, I can have a student registered twice in the course section, because I can take a registration and I can put the same student in multiple times in the same course section. Whereas with this model at the bottom, I can't. And so Umple will enforce that, and will just allow you just to have a student in the course section just once. And understanding that is actually quite important. So again, oops, too fast. Again, I have click link. I have examples that pop up in Umple that will bring us up for these examples that will allow us to play around with that. I'm not going to go through those, but the idea is that you just embed these in your you embed them in your PowerPoint when you're lecturing, and it just allows you to go right away. But then if somebody asks a question, no problem, I can play around with it, and I can make changes, and I can generate the code and whatever, you know. All right. And here's the definition. Here's the Umple syntax for association class, right? It just has an extra keyword, and it shows the students in the course sections. And you can actually have ternary associations. For example, I can have a team and the year and the position played if I wanted to. So we're following the UML semantics for all these things. Then another feature of UML which students need to learn about is reflexive associations. And so again, you know, here's the a typical course, you're going to have this diagram. Whoops, I clicked on it. Here is the Umple. We have symmetric and asymmetric. Asymmetric meaning that some courses are successive prerequisites, and other symmetric means that essentially we just have sets of courses that are mutually exclusive with each other. And again, I can open that in Umple, and it will bring it up in Umple Online, and I can play around with it. It looks as though here I'm going to have to redo the, where's this gone? Re-indent code, make it look a bit nicer. Yeah, you know what's happened there, though. For some reason, the size of my Zoom, I've got to rezoom it to make it look better. But you can do that rezooming to make it fit your screen as much as you want. We try to make it, for the lecturer, as smooth as possible, as well as for the student. I mentioned we have stereotypes. So stereotypes are keywords that will generate code specially. So the singleton code, anytime I do this with singleton, it essentially gives you the gang of 4 singleton pattern for university. You can only have one university in the system. You have a private, you have a private method, a private constructor, and a private static variable that will give you the university. And then the access methods will either create it or give it to you back. So you always get the same one. The standard gang of 4. And so when I'm teaching about patterns, there's this pattern. There's other patterns as well, but I'm not going to go into them because, again, we don't have infinite time today. So I taught a course with this summer to 100 students. I've taught this course many times. In fact, I first started teaching this general material, long time ago, back I think it was 1992, and OMT, and then UML came out, I switched it over and so on. But last time I taught it was during the pandemic, online, strictly with people all around the world and 100 students. And this is actually an assignment that I gave to the students. So I said to the students, okay, you're going to learn about user stories and basics of class diagrams and Umple as a modeling tool. So you're working on this assignment. You can refer to the course notes and videos. So I had videos up. And here's the manual for Umple. And we use Microsoft Teams for collaboration. We also use Brightspace for submission. And then we have case study too. We have a bunch of case studies that they can look at. And then different chapters of the book to look at as well. This is continuation of the assignment. So this stuff in large font here is the requirements. So this system is going to record information about tests. It was pandemics, just started. So, okay. And so all the students had and I taught them how to highlight the nouns and the verbs and so on and color code them, and then basically build the Umple textual code and iterate backwards and forwards. And they did it in an agile way too, because they added more features later on. So I wanted them to write user stories, create a class diagram in Umple, and write a main program to actually execute the thing. Actually, this is this slide here. So create a class diagram, write a main program, embedded in Umple to actually build examples of these things. And of course, they had pre-existing examples to work with. And this was quite successful. They were all able to do this quite well and submit them. One tactic I used during the pandemic was everybody was mighty stressed at the beginning of May. And so I said, rather than have hard deadlines, course ends at the end of July. If you hand it in by the end of the course, you still get graded, still get a grade, but you have a sliding scale of bonuses. The earlier you get it in, the higher the bonus. Right? And so it gave them motivation without giving them the panic, because we didn't know whether we were going to have half the class come down with COVID-19. Anyway, that's an example of actual assignment that was in Brightspace. And in fact, this is the Brightspace page itself. This is another assignment, but this is assignment 4, assignment 2. So assignment 1 was, this was assignment 2 I just showed you. So here's assignment 2. So, and this with a submission link and everything else. Okay. Constraints. This is an example of a constraint. So after I had taught up to that point about class diagrams, they got the assignment. Then I move on from that. So I started talking about constraints. And later on, they're also going to see constraints in state machines because they use the guard. Same syntax. In fact, a lot of the code generation is the same. So then I talk about behavior. And yes, we do talk about other features of UML. So I do talk about sequence diagrams, and I do talk about collaboration diagrams and so on. Umple will do sequences out of state machines. We'll see that in a few minutes, but it doesn't natively use state machines because I found, sorry, it doesn't natively do sequence diagrams because sequence diagrams tend to be at the instance level more often than not as examples. So you build your state machine and then you can play around with sequence diagrams of what happens at that point. So state machines, I teach the students, systems in one state. Actually, we will show you later on how you can have multiple state machines and multiple concurrent regions where you're in more than one state at the same time. But let's just imagine for now that we're in one state. I say, if you remember your physics, you know, in quantum mechanics, you can be in more than one state at a time. And yes, in Umple, you can be too. But for now, let's just think about Newton's original laws, and you can just one at a time for now. So we follow standard UML notation and syntax. So here's an example that I will illustrate to you, and we walk through this example live. This example is in the user manual. So I'm going to go back to my user manual, and actually, not user manual. It's in the it's in Umple Online. So I'm going to go into state machines, and this is phone and lines. So you can do this yourself if you want. Where is phone and line? Sorry, oh, I'm looking at it right there. Sorry. Okay, this is the example. You see it generates the same diagram that we just saw in the PowerPoint dynamically, and I can make changes if I wanted to. This example works best on a Mac because it's calling an Apple feature that doesn't work on other languages. But nonetheless, let me just show you this for a second. So this is one end, and I'm just going to hide the text so that we can see it better. This is one end of a phone line, and this is all the states that phone line would go through. And I actually did a lot of work with the Mitel. And just before I arrived at Mitel, they did reverse engineer their code to use state machines. And so this is very similar to exactly what they have in a real industrial company. And so one end of a phone line, I can be on hook and I can start dialing. And then once I can hang up, or I can keep dialing, and then eventually I finish my number and I'm waiting for connection. And then when I'm waiting for connection, I can hang up, or I can time out because the system says, sorry, you can't keep the line open forever. Or I actually end up communicating when the other person picks up, right? So communicating is when two lines are connected. Meanwhile, I can also get there through picking up the phone. So the phone's ringing, and while it's ringing, before I get there, the other party could hang up, or I can pick up, or maybe there's auto pickup, which is basically auto answer, which is a feature which you can have. Either way, I'm communicating with somebody else, and then these are the ways which the communication can end, including obviously hang up. So this is an example in Umple. I'm going to bring the text back, Control T. Few things I can do with state machines that are useful to help students understand this. So one of them is I can generate the code. So first of all, we see here that we have, so I'm not quite sure what's happened there. I'm just going to refresh my screen for a second. I have an issue with the browser. I've had this problem with Safari, and it happens in CNN, it happens in many websites. There's a bug in Safari, it's not Umple. It's Safari that's doing it to me. And the only way to solve that problem is to quit the browser entirely. So I'm just going to do that and bring it back. I should have actually saved the URL. Just bringing back my browser for a second here. and try.umple.org. Bring me back. I definitely should have saved it, but I can click on restore saved state. My saved state was an earlier state. Okay. By the way, while we're at it, there's ways of saving. If I click on store in browser, it will keep it in local browser memory. If I say source to copy, puts it in my copy buffer, I can also command script will save it to my terminal. There's a bunch of ways of saving these files in addition to save as URL. So I should have done that, but I didn't, and I forgot. Even when my browser had crashed, I could have still done it at that point because it still would have worked. But I just forgot. But that's okay. That can happen in Word as well. Let's go back into tools and state machines and phone and lines. And okay, what I wanted to show you before this happened, and this time I'm going to save as URL, just so that it's not likely to happen again. This happens infrequently. But there's a bug in a bunch of websites, not just ours. Let's generate some other interesting things. One of the things I can generate is state tables. Generate it. So this is, this first table is a state to event table. So if I'm in this state on hook, what can happen? Well, I can be ringing or I can be dialing. Either of those two things can happen, right? And if I'm communicating, what can happen? I can hang up, or I can wait. Either they can hang up, or I can hang up, or I can be put on hold. So those are the things that can happen while communicating. So this is a useful visualization that many people find useful. I've also got a state-to-state table. And by the way, David Parnas was very keen on tables like this. So this is an homage to him, even though, you know, I have had my disagreements with him over the years. A state-to-state table says, how do I get from one state to another? What events can take me there? And we use color coding in order to help people visually see this a little bit more easily. But it still works if you're colorblind. You just have to follow the rows and columns. So that's one thing that I can use to understand the state tables. Another one is the sequences. So if I do this and I generate it, I have two versions of a sequence. First version shows me, this is random now. It shows me that I started off with an incoming call and it was ringing. Then there was an auto pickup and I'm communicating. Then I got put on hold and I'm on hold. Then the other party hung up and I'm waiting for hook. Now I have to hang up because otherwise I can't dial again. So now I'm on hook. Then I start dialing again. This time I'm dialing out and I hang up and I'm on hook. And I start dialing again. It's random. And each time I regenerate this, I get a different sequence. And by the way, we're going to add random generation of instance diagrams soon. We have random generation of instance diagrams for formal methods analysis, but we haven't put them into the Umple Online, but we will. This diagram up here shows me which state I'm in and which events happen in a different way. So another way of understanding the diagrams that people find. So they got a textual way. And by the way, let's take a look at the state machine model here. My state machine model is here. A little bit easier to see if I were to stretch this. Let me just actually hide the text. Control T. Oops. Oh, hide the text. I want to show the text. Hide the diagram. There we go. So here we see the state machine is state open curly bracket. Now that is unambiguously not Java, not C++. So it's recognized as pure Umple, and it's the state machine syntax. First state is on hook. And by the way, I can double click on that to hide it if I wanted to. This is the feature that, you know, if I want to hide that, I can do that as well in Umple Online, just so that I can focus on particular ones. Here we have the on entry, we're going to do this action. On pickup, we're going to do this action. On other party hang up, we're going to go to this state. And auto pickup, we're going to do this action and go to this state, right? Okay, so now I'm going to run this. So it's Control O, over to a terminal, paste, compiles on my local machine, right? Now, people have said, can you compile on the server? We do compile on the server, but can you run it on the server? And I'm saying, okay, security problems galore if I start running code on the server. So right now, we're thinking of setting up some kind of highly secure, sandboxed way of running programs on the server. But essentially, because you can embed arbitrary code, it becomes a security challenge on any server. But anyway, on their local machine, they can do this easily enough. So now it says, main method found, and this just tells me how to run it. So I'm going to click on this, and you should hear the sound.
Line 3 dial.
Line 2 ring ring.
Line 3 click.
Anyway,
Line 4 dial.
okay.
Line 2 ring ring.
Okay.
Line 4 click.
Okay, so it's kind of funny. You can let that run and it will just keep simulating random people calling each other, speaking English and French. And people like it. But there's another feature that's worthwhile noting here, and that is we have automatic tracing. So notice down here, we see it's got this funny cryptic number. This is the object. And then then it says it's in test.ump line 71. And it basically gives us information about what was going on, what state we were in and what state we went to. Where does that come from? Well, it comes, let's look for the word trace. It comes here. Trace, wait for hook and ringing and record the ID when this happens. So I can trace and automatically generate, I don't have to write print statements. This trace will work and will give me tracing of execution using a number of different tracing technologies built into Java and other languages. So I can actually instrument code that will allow me to just to figure out where things are, what's going on at any given point in time. And it generates native code in tracing tools for this. But you saw that output. There was no print statement here. It just uses the native trace in Umple. Questions? All right, you want to talk about concurrency? Well, we talk about that in a second course. I briefly mentioned that concurrency is a thing in an introduction course, but Umple, as does UML, supports concurrency models. Umple supports more than one concurrency model. It supports a distributed concurrency model, but it also supports a concurrency model that's built into state machines. And so essentially what happens when you define a do activity, which is a UML feature, is that Umple will generate a separate thread while you are in a state, and it will execute until that state exits. And so this thread then is concurrent with all the other threads that are running. And it we had a lot of work put into this. And it's quite powerful. And in fact, you can use Umple purely for concurrency if you want, purely for concurrency in Java. And then when I had a PhD student do the C++ code generator, they actually wrote their own library for concurrency because they wanted one that was better than what was available in C++ at the time, which matches the Umple semantics, the same as the Java one. So essentially, you can follow, you can have multiple do activities, in fact, that run concurrently with each other. And this will run until the method terminates or until the state needs to exit. And when the state exits, because of an event happening or a timeout, the thread gets killed, gets sent a kill, whatever's doing it will stop, right? So, and it's quite useful and it works quite well. And it makes things a lot nicer than having to teach people to program low-level concurrency in Java directly or C++ even. Talked about state tables and simulations. So let's move on to a little case study where we now are going to bring in, well, I talked about the tasks already, but this is another assignment I gave students. Actually, I gave this dishwasher example in a tutorial in the course this summer, and then I gave them an assignment following on from this, which was to Yeah, you can do appliances. Let's do an oven. So I said, create an oven that does microwaving and convection and radiant heat all at the same time, and whatever combination you want, with timeouts and stuff like that. And the only thing is, it's going to simulate minutes with seconds. So if you want to cook for 20 minutes, it's going to take 20 seconds. Other than that, it's going to work in real time. So, and this example is available in Umple Online. So let's go to let's bring back the diagram for a second. Control D, and we have tools and state machines, and select example and dishwasher. Okay, so this is my dishwasher. Now I have more than one state machine here. I have a state door open and closed, and I have a dishwasher core that has various states like draining and idle and pre-wash and main wash and rinsing. And then I have the timing state machine, which is for counting down time, which gets interrupted if the door gets open. So I have 3 state machines. And if I want, and it's useful for students to see that there are 3 state machines. Notice there are lots of comments. So I, following good practice, comments in the class, comments. Here I have some constants. This is the pre-wash time, the wash time, and the rinse time, which I can modify. So don't hard code things, put them in as constants. Then I have, now this has got introducing a new keyword, queued. What does that do? Well, it gives you better concurrency. I can have all of these 3 state machines moving around different states concurrent with each other without getting into deadlocks. Essentially, what it sets up is a queued semantics where I don't instantly transition to a state when an event occurs, gets put in a queue in case there's very small delays. So there's a thread that's pulling things off the queue automatically as fast as it can. And these activities are supposed to be instantaneous, but in reality, even though UML says activities are instantaneous, even assigning a variable can take some time in reality. So therefore, we have you want better concurrence behavior, you have to call your state machines queued. So this is a stereotype, right? Stereotype for state machines. And I explain what can happen. And then you take it off, I'll show you can get some deadlocks. So you use queued, you have more threads, and everything works nicely. So that's my my state machines, and this example can execute. So let's just go do the Control O again, and my terminal again, and I'll get out of that one. I'll paste it. This is my. You see now also we have a main program in here, main program that's going to create it's going to initiate, do some system.out. Then it's going to loop around getting input from the user for commands, and then it's going to interpret the command, right? So this is a simulation. It says here, success, process test.ump, run Java dishwasher. All right, I will do that. Oops, not jaded. I got to select the right text. Java dishwasher. Click on that, and it prints it out. It says C, Q, DO can interrupt or cancel. A cycle is going to be normal. N, F is fast. R is just rinse. Let's just do a rinse cycle. R. It says rinsing, it starts counting down. I can cancel that. It goes into draining right away. Let's go to a normal wash. There's a pre-wash, and I can quit. All right. And one of the things I teach students is you're going to allow that. You've got to have your user interface running as a separate thread. You've got your internal controls of your dishwasher that are running through a series of state machines to control the motors, but you can't wait. Your dishwasher has to have instant response when people press buttons or open the doors. And so we have essentially, we have our dishwasher running as its own thread in here, and that's because all of the state machines are queued. So they set up, as soon as it's queued, they set up their own threads, and they start. And what's remaining is my main program, which is the user interface, right? Now, I also show them how you can build separate user interface classes and so on and so forth. But the point is that you got concurrency going and you have to have it. Otherwise, I couldn't interrupt my wash, right? And if I open the door, it's going to start spurting water out. Door open, it's got to interrupt the state, whatever I'm doing, right? So these are important lessons for those kinds of systems. And I also give them more advanced students examples of automotive. So, you know, well, you've got safety setups, windows opening and closing and doors opening of the car and all kinds of stuff. When can it be allowed, when not allowed, and so on. So you can model lots of things, real-time systems in Umple, and really learn about feature interactions and deep concurrency. One of the things I didn't show you is that I can have deeply nested state machines. So this example here, and I'm just going to move my screen a little bit so that it's filling this thing up nicely. Oops, I've got the wrong thing there. I'm going to drag it again. Okay, here we go. I think I should be okay now. Drag that over. Well, there's my diagram. That's the top. And this is the diagram. There we go. Okay. So this is a digital watch. Okay. Now, this came out of a paper. You can find it. It's right there. It's in Empirical Software Engineering 2009. The paper gives this diagram of the state machine. I took half an hour. I typed it into Umple. Didn't take very long. It's only 126 lines of Umple. Here's the diagram that it generates. And it's probably helpful to hide the text to see the diagram better, but you can see that it's nested, right? So you can have nested state machines to any level of depth with concurrent regions at any level of that depth, and it all just works, right? And so in advanced courses, you can really get into really interesting designs that are really experiential for students because they can really see these things. It doesn't take a lot of effort to design this thing. It's only this many lines. You don't have to code much. Let me generate the code for this for a second. In Java, how many lines of code do we have? 900 lines of code, okay, to build, to represent this in Java. And I had a whole PhD student figure out how to do the code generation. We do not use the state pattern. State pattern was less efficient, resulted in more bulky code. We wanted the maximum efficiency out of this because people, the code is readable, the generated code is readable, but it doesn't use the state pattern. It uses a bunch of enumerations and automatically generate methods for different transitions that switch the enumerations to the right thing. Uses case statements. You couldn't program this by hand, okay? You can do the state pattern by hand. Although this is readable and debuggable, you know, the native Umple is what you want to work on for the state machine. Questions? All right, let's go back. So that's the dishwasher example. And then I say to them, okay, that's how you do appliances. Build a different one, build the oven one. And so here we have this is the assignment 4 I gave them in the summer course. So this was for students who are second-year students. They've taken CS1 and CS2. They know how to program in Python and Java. And now they're going to build this essentially real-time concurrent system with that does all these things. And 90% of them were able to get it working with Umple. These are the user stories. So the requirements were the feature descriptions, the user story descriptions. So I'm saying be agile, do a bit at a time, get it working. And I actually focus really strongly on saying, you know, make it work just for radiant heat first. Get the basic state machine in there, get it working, get the user interface in for radiant heat. Then we're going to move on. You're going to add another piece of the puzzle and another piece of the puzzle. And you're going to do this on GitHub, and you're going to actually do pull requests for yourself for different versions of this. And so you can see your passages, you start adding new features. And guess what? Well, you can actually use Umple's Umple's product line features to say, well, I want to build a version of this that doesn't do microwave and only does the other two using mix sets, which we'll get to in a little bit. All right, and so here is my deliverables, my design hints, gave them all of that. And I gave them the dishwasher example to start with. So anyway, there you go. That's the start of the, that assignment. That was the 4th assignment of the course. They also did an Android assignment where they used a user interface code generator in Android, just so you get the sense. It wasn't all Umple. Again, these are students who, this is only their 3rd programming course in many cases. And I say, with software engineering, they were learning the core software engineering concepts, but it was experiential. They were doing the modeling, they were generating the code. And yeah, they had to write a bit of code, main program code to simulate it. But most of it was just done with modeling. All right, so we have, does anybody want to take a short break? If you want to take, I mean, I can keep on going, but normally if this was a real class, I would have given you a break after, a break before now. But I think I will keep going. I will just pause for a second to have a drink. In a class, I wouldn't dare go on for more than an hour and a half without giving students a 10-minute break. But this is video recorded anyway. I'm assuming that we will get to see the video later, hopefully at least. And yeah, I see it, yeah, being recorded in the cloud. So, you know, if you miss something, you can go back and watch it later. So that's good. All right. Now, another feature which is common in some languages, PHP is famous for it, but also you can get it with Ruby, with RHTML, and is the ability to create output text. So obviously that's useful for generating web pages, right? HTML or CSS, right? So you want to produce text, and so Umple has this natively built in. Why? Well, as I told you a while ago, we built Umple in itself. So originally we used Jet templates, and we ran into huge roadblocks because quite literally the Umple compiler, when generated, has approaching 1 million lines of code. The Umple input is 100,000 lines, but it generates 1 million lines of code as to compile the actual compiler itself. And it was, you know, Jet couldn't handle that. We reached the capacity limits of the Jet technology in Eclipse. So that was the main motivation. But the secondary motivation was to say, we want to be able to access model elements. We want to be able to do this stuff with state machines, with associations, and other UML features. So I'm not going to go into this in detail, but I am going to show you by example. I'm going to show you 2 examples. They're both very straightforward. It's in the user manual again. So we're going to go to the user manual, and we're going to go down to generation templates, and we're going to see, first of all, basic templates. So here you see a description of the syntax. So this looks very much like what you might expect to see in certain languages like PHP, right? PHP uses slightly different syntax to introduce the beginning and end of a template, but it works the same basic concept. And so here is an example of a multiplication table where I have a template, 2 templates, template for carriage return and a template for header and a template for row, actually 3, CR, header, and row, right? So 3 templates. And what's going to happen down here in the main program is I'm simply going to use those templates to output this. So I'm going to actually grab this example, and it's just, there's not much modeling in here, right? This is just code with templates. But I'm going to do the Control-O, and then I'm going to go to my terminal, and I'm going to press paste, and it compiles as before. And this says run Java math example. So there we go. And it will give me a times table, right? So that's one example. Another example is a little bit more interesting. Back to the user manual. HTML generation. So we've got a library here. You can actually use this for generating HTML for web pages. You've got nodes and text nodes and so on. And all of these things have the relevant text that you would need to recursively generate tags. And I actually use this. I built a system that went into production at the university for building printed exam timetables for students. So that was written in Umple, and it was in production for several years until they switched over to a totally new technology about 6 months ago. PeopleSoft Campus Solutions. So that obsoleted the Umple system. But essentially, we built the website, and strictly using this little library of HTML tags that can be done. And so we had students, we had course sections, we had courses, we had exams in different rooms with capacities, all modeled in Umple. And then we had a scheduling program that was written in Umple, and output of the web page to tell students where to go and when was done using this little library of HTML generation. Right? This is an example of production use. It's in the manual, you can play around with it. And I use that as an example in class too. I made a point in the HTML page saying this page was generated using Umple technology, so everybody got to see it. Okay, mix-ins. So we've gone into the blue now. We were in the purple before. Now we're in the blue. The blue is the separation of concerns technology that we have in Umple. There's several of them. Mix-in we've had since the very beginning. So in Ruby, you have what are called redefines. So if I declare a class and I declare it again, rather than getting a compiler error saying you've already declared that class, what you get is you get additive elements into the class, right? And that's, some other programming languages do that too, and that's the way Umple works. So for example, if I say class X A, class X B, well, I get it twice, right? So I can go into Umple Online and I can actually do that. There's my cursor, there's my cursor. All right, got a blank page, that's good. I can say class X, which has A in it. Oops, there we go. Class X has B in it. Oops, it's going to give me a syntax error, no problem. Passing error on this somewhere here. Let's do that right. Notice it made it go red. There we go. There we go. We got class X, which has A and B. These could be in separate files if I wanted to. So I can actually take this and I can say here, call it other, paste that there. Here I can say use other.ump, and there it's the same thing, right? So this is my main file and the other is the secondary file, right? So I can divide things up as I want. So this other could be a separate feature. And so I'm teaching students to say, well, you know what? You know, in Java, you write everything in one class, but if you want to do feature-driven development, you can write separate files for separate features. And that's the way the Umple compiler is written, right? So the state machine feature is in a separate set of files from the trait feature, which is in a separate set of files. And so we use feature-driven development, and there I have it for example. Let's go back to PowerPoint for a second. So there's that example we just saw. So they can both be in the same file, which is what I did first. One in one file and then including another, which is what I showed you second. And also I can do it in two separate files with a third file invoking them. And that's what the actual Umple compiler looks like. Earlier on, I showed you master.ump, which basically brings in all the features in the master, right? And that allows me to do product line development because I can just simply say, I don't want that feature in this version of the product line. I'll get to that in a minute. So mix-ins allow you to do smaller files. So you can avoid your God classes and you can avoid, you know, you can really have little files that just focus on little pieces of functionality. And yeah, there's an opposite, you know, anti-pattern that says too many small files, you can get confused. But then you have your IDE, which allows you to group things into directories, and you can put different group related features in related directories. And organizing is key. Organizing models and organizing code. I said programming and modeling are the same thing. So here we're doing organizing. And as I said, I can move into variants and product lines. In the simplest case, I can simply comment this thing out, right? And that now my B is going to go away once it redraws, right? But, and then I can undo that. Let's just demonstrate the undo to bring it back again. In a minute, I'm going to show you mixed sets, which gives me much nicer control over the feature set. This is stuff I would teach and I would briefly mention in the end of my second year course, but I bring it much more into a more advanced design course. All right. So why do them? Well, one of the things we might, aspects. Mix-ins we're done with for now. Aspects. I don't like the code as generated. I want to be able to modify its behavior so I can use mix-ins, and it's the same as an aspect J. I'm not going to teach you aspect-oriented programming. Look it up if you don't know it. But basically the idea is that I can inject any code I want before, after, or around any matching methods that match certain patterns in any matching classes that match certain patterns, right? So I've got to create these patterns. They're called point cuts, and I'll show you an example in a minute. But why? The code is generated. I want to do it a bit different. Now, as soon as you start doing this and injecting your own code and overriding the code generator, then you lose your formal methods, right? My formal methods generator relies on you generating code as written. And most of the time, that's what you want. So you got to give up your formal methods analysis if you want to do aspect-oriented programming. But that's okay. That's your choice, right? It's a design decision. It's a software engineering decision. Another thing is that I might want to do more than what the generated code. The generated code might be fine, but I want to do more. I want to add security checks. I want to add logging or something like that. And so really that's these other cases. So I teach them about that. Then I show them the point cut notation in Umple. It's not the same as the point cut notation in aspect J, but it's very similar in many respects in terms of its functionality and its semantics. So let us just go back to the user manual. So our user manual is here, and I've not called it aspects. I've called it, oh yes I did, it's aspect orientation. Okay, so there's a bunch of pages on that. But let's pick the very simplest case. Second simplest, code injection with pattern matching. So you can see what it looks like. So this says we've got a first name, a last name, and a city of birth. And we've got a constant debug. If that's set to true, then we're going to print out accessing the name. But we're only going to do that. We're going to inject that code, this line of code here, in any get method that ends with name. So it's going to put it in first name and last name only, not in city of birth, right? So that's what they look like. And now these things can be combined with mix-ins, right? So I can have my student class pure and simple, and I can throw this aspect in a mix-in somewhere else. So all of the Umple features work with each other synergistically. And that's one of the things I try to tell people. In fact, I say, separate out your methods from your model code. Separate out your aspects if you want. You don't have to, but it's a good idea to separate them if you want to keep things simple, you want to modularize. So the aspects can be modules themselves, as can the core of the class model, and as can the individual methods. I can have individual method, one per file if I want, which is a pattern that I used to like in Smalltalk language. One method per file, really nice to look at. But I have to teach students that there are drawbacks to aspects. And one of the biggest drawbacks is delocalization, which basically means that I have pattern matching. And the pattern matching I can, it says anything that matches this pattern, your code gets injected. The problem is what if somebody accidentally adds something else new that happens to randomly match your pattern later on? All of a sudden they get the code behaving in a strange way. Why? It's because it happened to match, right? So you do need to have tools support that analyzes which things get matched. Delocalization can be a challenge in any separation of concerns, but particularly in aspects. And I gave you the example in Umple Online, so we don't need that slide. Now, the next feature is traits. So traits is basically, imagine that you've got interfaces. So interfaces exist. They behave the same way they exist in Java, right? So you declare a class implements an interface, and voila, that you're forced, your compiler will give you an error if you don't implement that by the time you get round to the concrete class, right? Same as in Java. Traits can be looked at as interfaces on steroids. So in traits, you declare a class implementing the trait, but that class can have anything in it, including attributes, methods, associations, implemented methods, that is, and states and state machines. In fact, anything goes. Anything that you can put in the class, you can put in a trait. And the idea is it allows you to build up classes from parts. And unlike mix-ins, the semantic analysis is very, very strong. If you look at the user interface, you look at the user manual on traits, you'll see it does tons of analysis to make sure that this is consistent. There are other languages that do traits, so we followed some of the conventions, but it's traits with models, whereas most other languages do it with either just pure methods or methods with maybe some state, have attributes. So we have state machines as well. Anything goes. And indeed, even to the point of having mix-ins within traits, within traits. Everything can be synergistically combined. You don't want to go there, perhaps, too complex, but there's nothing to stop you if you really had a use case for deeply combining these things. So why do you want to use traits? It allows you to essentially do multiple inheritance in languages like Java without the pain. You get all the analysis telling you about potential conflicts that are very nice, but it also allows you to bring in chunks of models, and there's a renaming capability. So I can create a state machine that is common, and then I can rename the states and events to match needs of a particular application. And that's because there are state patterns, right? So I can have on-off of a light bulb, or I can have, illuminate and disilluminate, if I wanted to call them that, in a different application. So renaming of things can be very, very useful. In the transportation domain, I often talk about the fact that you can have, and I give examples of buses and trains and planes. Planes have flights, and trains have runs, and buses have runs, and trains have stations, and buses have stops. Well, with traits, you can build a transportation set of traits, and then you can name them right so that it turns out as flights in the one domain, and stops and stations in the other domain. So that's what traits do. I'm not going to go into any details because it's an advanced material and we don't have the time. But this is an example of a trait called identifiable. It has these things, and I can apply that to person, but I could also apply that to something else if I wanted to. And here's an example of associations in traits. This is actually the implementation of the observer pattern, right? So I can say here trait subject with this observer as the template that I want to implement. And up here, I've said a sensor is a subject taken this trait, and the observer is going to be called dashboard. So I'm now injecting the dependency to the class dashboard right here in this piece of model, okay? And other things might have might connect to other kinds of classes. But basically, it's a way of doing observer that's quite concise and generates all the relevant code that you want. I mean, I haven't put the code for notify observers here, but it's quite concise, right? So you can do many other patterns in a very concise way using traits, using the template parameters. Any questions before we go on? And then I can mix them together. So let's pick this example here. All right. So here what I've got is I have got trait T1 and redefined it again. So we have a mix in, more stuff for trait T1. And that, which could be in a separate file, but just for argument's sake, I'm showing it in the same file. Here we've got a method 1, which is abstract because it's got no body, which means that I'm going to have to implement that like in an interface in a concrete class. So here I have a class that's going to implement method 1. Okay. T1 is going to have method 2 with a concrete class. It's just got a comment in it, but it's still a concrete class because it's got curly brackets. So method 2 is automatically going to be present in anything that uses this T1, and so is method 3. So I load that into Umple Online, and we're going to see not very interesting right now by default. So I'm going to have to go to my options and switch on the diagram layout. I'm going to let's say show me the methods. Ah, there we are. There's method 1, method 2, and method 3 in the class. But heck, let's see the traits. This will show trait T1. Okay, so stereotype trait. T1 has, and it grouped the methods into 2 groups. Okay, the first group are the concrete ones, and the second is the abstract ones, because it needs to emphasize that we need a client that's going to implement this. So you got to implement C1, and you get 2 and 3 in your class. And just for fun, we can always add an attribute if we wanted to. Click on that, and we immediately have an attribute that is there. You know, kind of nice to see that. Yeah, I think that's all I wanted to show right now. All right, let's go back to PowerPoint, unless there's questions. Questions. Okay, so we got mix-ins, we got aspects, we got traits. What about mix sets? Notice I've underlined the word sets there. It's basically mix-ins that are named. A mix set is a named set of mix-ins. And what happens is that I can then define a feature as a mix set, which will allow you to introduce into the system a set of mix-ins that provide this feature functionality. And this mix set can all be defined in one file if you want, but you can also distribute it around the system. And so we're working. I have a PhD student who's right now working on his PhD thesis and writing papers. We submitted one and got rejected from TSE on this, but that's okay. Everybody gets stuff rejected from TSE. He'll hopefully get it accepted somewhere else. But basically, if you know the product line literature, you know that there is 2 main kinds of ways that you can specify product lines. One of them is annotative, and the other one is compositional. Well, mix sets allow you to mix and match and do both. Essentially, that's what's going on here. And the syntax is very intuitive and easy to use, and we can teach it in a second-year course. So that's why I said I can teach students to switch on and off features. So let's just go back here for a second, and we'll go to the example we were looking at a while back, which is here. So I've got this X and other. Okay, if I said mix set stuff, curly bracket, end curly bracket, re-indent code, okay, and then I said, and I can put whatever I want into this mix set. I've got a use statement in it, but I can also put in a class Z which has got a, you know, a C, a D, and an E, and then I can have an association, I can have a state machine, all kinds of stuff. It doesn't show up right now. Why doesn't it show up? Well, it doesn't show up because I haven't activated this feature, right? I do have the ability to generate a, where's my feature diagram? Where did you put it? Did you put it? He may not have put feature diagram in here yet. There we go. Oops, wrong one. Generate, not entity relationship, feature diagram. There we go. All right, generate it. Okay, there's no require statement in here. Okay. So for a require statement, I've got to say, if I say require, and I believe the syntax is going to look like, this is a new feature, so I haven't used it much. Oops, not WAF, stuff. What's that going to say? Okay, require stuff, right? So that's, notice that any constraints are in square brackets. So now let's see what happens if I were to generate a feature diagram. And okay, so this is now saying it's not valid because I actually haven't yet activated the stuff feature. It's saying this is the feature diagram, but is not a valid configuration of my feature. So what I got to go down here now is to say use stuff. And now we have it. We have X, which has A and B because the part of it's coming from the other, right? And we have Z, which has got C, D, and E. And so it's a valid configuration. So if I generate my feature diagram, it should say that it's valid, right? And so that's, in a short, how I can play around with these things. Notice the use statement's used twice here. It's used for including files, and it's used for including mix sets. Turns out that that's a deliberate decision because the semantics are the same. The only difference is that the .ump simply means that it's in a separate file rather than being glommed together in the same place, right? The semantics of feature inclusion are the same, whether it's file or bits of code picked up in any combination of files. Any questions? Okay, I understand somebody saying they're leaving because it's a long day. I completely get that. But I'm going to push on because people can watch the video later on and it's really nice to just wrap up. But if people want to ask me questions, how many people do we still have here? A few people. Okay. Let's jump back to PowerPoint. And so why do we want to do this? Well, we don't want to use C preprocessor. There are tools, pure variants, there are a variety of tools out there. But we wanted a native capability that really works nicely with all the other features. And we wanted to push the research in product lines itself and have model variants with a harmonious syntax that really works well. So I think I've talked about this enough. There were the use statements, and you can play with these things together. So you've seen that. And so for teaching material, I have an example where I use a bank account example where I can say, well, here's a basic bank account that's got accounts and interest-bearing accounts and deposit accounts and loan accounts, and it's got a trade even for interest-bearing accounts. But I can switch on certain features. So, for example, I can have multi-branch banking. I can sell a feature for more. So I actually had that set up here. So here I have my various different things. I've got mix set multi-branch banking. Okay, so it's adding some stuff to it's adding a bank class with accounts, the basic version and the more advanced version. And the fact that I duplicate doesn't make any difference, it still work. And here I have a mix set called multi-branch that is going to add some branches, and it's got a require statement that's saying I got to either be multi-branch or overdrafts allowed. Okay, got to have some. I got to either of those has got to be the case. That's the configuration that we're going to sell. It's going to be either one or the other or both because it's not XOR. it was XOR, it would be, can only be one or the other, but here we can have them both, right? So I can make essentially three different combinations. Just multi-branch, just overdraft allowed, or both. I think that's good enough for that. So let me summarize what we teach about. So in my Introduction to Software Engineering course, they're learning about all the basic object-oriented principles, polymorphism and inheritance and list-of substitution principle and all those things demonstrated in practice through Umple. They're learning about UML, associations and patterns, basic set of them. And I can do this really fast because I can generate the code. And then they don't have to write the code. They just do a stereotype. Agility, little bits at a time added, okay? They can test, design, test, refactor. Because they get it wrong, it gives them error messages, either in Umple or in the generated code, and it points them back to the original source. Got some basics of constraints and state machine modeling and some depth I go into. Concurrency, the basics of that. We saw that in the dishwasher example, and they do it in the oven example. And then testing. I haven't shown you testing yet, but you can apply JUnit to this or CPP unit, and I'll show you that in a minute. Because that's something that is really done actively in my capstone course. So let's talk about this. I said Umple is written by students. Yes, it is. Most of the people who contributed to Umple are students in capstone. Now, I teach the capstone course most years, and it's not just Umple. I have many, many people who serve as customers, and only some of them have done Umple, but that's fine. When it's Umple, I serve as the customer, although sometimes my PhD students have. We run the capstone with usually 3-4 students at a time, sometimes 5, but I've had a couple of cases recently where it's been 1 for various reasons, health reasons, or strange issues have cropped up, but usually it's 3 or 4. I have pointed them to the documentation. So the documentation's on the wiki, and I said, go read it. It's all there. Play around with the examples. I don't need usually to spend much time teaching them Umple. Teaching them, the compiler, I say, follow the links. It's self-documenting. And I'll help you when you get stuck. Then I start them with a small bug. And I say, okay, go look up the code. You just follow the links because it's all there. The issues, usually when they're analyzed, it points them to the code. I teach them to search using tools like grep, okay, or in their IDE. Search-based software engineering fundamental, but they get that pretty fast if they don't know it already. And the whole class, whether they're doing Umple or working on other projects, I say, you're going to be agile. That's a requirement in this capstone. No matter who your customer is, you're going to have a prioritized list of features and bug fixes and things, and you're going to work through a Scrum-like approach to have a backlog, and you're going to do a release every month. It's a course that's going to take you either September through April or January through December, right? And you're going to do at least 5, if not 6 sprints in that time frame. And students are discussing their progress every week in the class and the challenges they run into, and they're doing pull requests and following the standard GitHub protocol. We try to do everything the way out, the best practice for open source, the best practice for Agile, and on top of all that, model-driven development, if they're doing Umple, right? So test-driven and model-driven at the same time. That is the novelty here. They're modifying the models. So what code do I showed you the code in GitHub. The wiki, I showed you that briefly, and the architecture page and the meta model page. And well, heck, the Java doc page, which brings you into the documentation internally. So I showed you all these pages earlier on in this tutorial. What about the testing? Well, we have qa.umple.org, which is telling me that it isn't secure. That's all the reason why I told you that. That's on a little bit of a legacy, but it will give you, for one of our, we have 3 continuous integration servers. We use AppVeyor for Windows, we use Travis CI, and we use an older one This is showing it on the older one. But nonetheless, it is here. It will tell you that, well, different classes of tests. So we have 4,640 unit tests, which we can break down and we can look at those in many different categories. So this is testing an Umple system written in Umple, right? So we're going to write unit tests that are going to connect and ask questions about the model features that are there. And I'll show you one of them in a minute. If I click on this, we can navigate into the thing, and these are the various assertions in the test and the time it took. And on September 17th, 2020 last, so a few weeks ago. Actually, I show this stuff in my second year course because I walk them through the process. I say, look, you know, you want to do a lot of testing and you want to have a test, test-driven development means everything you do, you're going to have tests. There's a few tests that are skipped because they became obsolete and we need to investigate them, but that's not very many. Most of them are active. So this is Umple core test for the compiler. Then we have tests of Java. So what's going on here is we are generating Java from Umple and we're running the Java. So we're running actual running programs now that are generated from the model. So 643 of those, and they're not trivial. A lot of them are quite sophisticated. And then we're generating PHP and we're running tests of those. There's a problem with on this server of the XML parser for this output, but it runs the PHP test, and the same thing with Ruby, right? We're generating Ruby, the C++ is done a little bit separately. And then we have some sample projects, and we compile Umple itself. So all these tests have to pass 100%. Then it says, okay, compile Umple compiler, and then rerun everything and test it all over again. Make sure the new version of the compiler still passes all the same tests. So that's how we can manage with students to create a system which is reliable enough to be used in industry. It's because we have 100% pass rate on test-driven development and model-driven development, which increases the quality tremendously. Because they aren't writing vast amounts of boilerplate code. They aren't writing code for state machines. They aren't writing code for attributes and associations. They're just modeling it and getting that code generated. So the only native code they're writing is a bunch of methods which get tested. But it's cutting out somewhere between 70 and 90% of the amount of code they have to write, which reduces the risk of the code in that respect. Before I go on, so I introduced the capstone students to this. They learn it, and then they have to start working with it, right? These are some of the learning objectives. So they're modifying a complex code base. As I said, 100,000 lines of Umple with embedded Java, of course. When I say 100,000 lines, probably about 5,000 lines of those are actual Umple. So declarations of state machines, declarations of associations, and the rest is embedded methods that are doing other things, right? But they're doing model-driven development, test-driven development. They're using all of these things, and they learn about parsing and grammars, right? Because we got our own embedded grammar generator and so on. I showed them the Docker. Then there's DevOps. All right, so we've got a server running, right? Well, we have to do DevOps on that, meaning I have to keep this server running and update it and so on and so on, so that some of the capstone students get to learn how to do that, and certainly the PhD students do. And then they have to do front-end development code in JavaScript, UI design as well, which is relatively minimal, but most of the code is the complex code is in the compiler, but they do front-end stuff as well. Grading scheme I use, the customer satisfaction. So I've got to be satisfied, and I don't merge all the pull requests. If it's non-Umple capstone, it's the same thing, right? I have a Google form that everybody fills out who's a customer to map their satisfaction in terms of the product and the process and the behavior of the students. And whether what the students do is able to be continued beyond the course of the capstone, because it's going to be maintained. 20% is project management, agile processes, professionalism, and disputes among teammates. That's judged by the professor in charge, which is me. So I get given both these grades. Then the design, which is, are they following good design practices, presentations, communication. So this is the code commenting, and the documentation in wikis, and recording design decisions, which is done in the issues, right? And comments on issues. So let me take you to that for a second. bugs.umple.org. We'll take you through to the relevant GitHub page. So you see these, we have 273 open issues right now, 693 closed since we moved to GitHub. You know, I teach them about the proper tagging and the prioritization and so on and so forth. It might be more instructive to see some of the recent closed ones. So I can go to that. And you can see some of the ones that have been done recently. Back here, let's pick on this one, for example. So I raised this summer, usually in response to an end user complaining. We give example of code, example of the generation problem, and then it was fixed by a pull request. Did I do this or did a student do this? It says it was closed by what? Tim Lethbridge closed this here on August 24th. Yeah, it turns out that I fixed this one, but nonetheless, it was a case where it was relatively straightforward. Notice I had to modify the error messages as well. I had to add an error message here, and then this is the test examples, right? So test-driven development. So I had to submit tests with the change. So this is now going to compile, and it's going to test that in fact it's compiling correctly. So I'm going to wrap up in just a moment. So back in the beginning of the evening, 6 o'clock your time, pushing 9 o'clock now your time, I said 3 things I want to get better in terms of teaching software engineering. I want to do agility better. And so this whole setup of Umple has all been to make sure that it blends in and it enables students to do proper Agile, even when they're doing model-driven development, right? And tests, because I mean, Agile includes automated testing. It's fundamental to Agile. So yes, they can do test-driven development. And they can use GitHub, do things properly, and they can do things in small increments. It's there. At the same time, I want to teach design abstraction better, and textually and graphically, they got a choice. And it's not overwhelming like some of the tools, or overly expensive like some of the tools. And it's multi-platform. You can do this in Eclipse, but you can do it on the command line, and you can do it online, and you can do it online in your own machine using Docker if you want. So they can do it freely and easily. And as I said, I did research, I published research that shows that it really helps them get better results in their models. And finally, feedback. Feedback from working systems. Experiential learning. They're really working with models. They're really working with Agile, small increments, and they get analysis of models. It tells them all the errors, and either the model compiler, or if they've embedded code, the Java compiler or what other compiler is going to give them feedback that points back to the model. Okay, and at runtime, I mean, maybe everything's working. Compiler compiles, model compiles, everything's good. Runtime. Indeed, if you run on the command line and you get a stack trace, it will point you back to the Umple file if you're doing it in Java, and they can see the Umple line where the problem of the stack trace problem occurred. That's it, except for questions.
How many hours have you invested into this system and your students?
Well, That's an interesting question. And I'm going to show you a web page. Just a second. I'm going to go to, it's easiest to find through www.umple.org. I go here and I click on, down here, there's a link to, I think it's in the social media thing, Open Hub. And by the way, we're active on social media. So this is Open Hub will analyze open source systems for you. This says, okay, in a nutshell, Umple has had 5,205 commits made by 110 contributors, representing a million lines of code. Well, right. I said 100,000. It's because there are other subsystems and other example systems and all the tests. So the compiler is 100,000 lines, but there's 900,000 lines of tests. So it's a million lines of code, right?
Together probably with the documentation.
And the documentation's all there as well, right? So documentation, which is a DSL. So a million lines of stuff, right? 110 contributors, as I said. Some 60 undergrad students and so on. So we've had some people in industry as well. Mostly written in Java. Unfortunately, Ola doesn't recognize Umple. It sees it, looks at it and says, that looks like Java, so we're going to tag it as Java. That's fine. With an average number of source code comments, well-established mature code base, large development team, took an estimated 289 years of effort following Kokomo. So there we go. Well, it isn't that. It isn't 289 years of effort.
Yeah.
I can guarantee that, because otherwise 110 people would have been working for, it doesn't multiply out because most of these people have been part-time. I mean, in terms of full-time work, there's probably only been maybe 10-person years of full-time work on it. Everybody else has been working part-time. But I would say there's been something like 30-person years of work, so a tenth. And the reason why this analysis using Kokomo says 289 is because it's model driven, and it's so incredibly easy to make systems that are reliable and model driven, and it's test driven, and it's so easy to make reliable code if you do a test driven, and it's agile. Again, all of those three things synergistically working together mean we can build a system with a million lines of stuff with only 30-person years of work instead of 300. And we're doing it with students who aren't even professional programmers. So,
I have a question. So I'm from Penn State Abington, which is a very small school, and we just started teaching software engineering course. We didn't even have 4 years degree a couple of years back. So I'm the first one introducing software engineering courses at Penn State Abington. So I was wondering, using Umple, do you have any syllabus or a full course of like assignments, solutions that I can just adapt and then implement?
That's a very good point. I can send you my, all of my stuff is all in Brightspace. And I can send it to you if you like. Just send me an email and I'll just do a dump. What learning management system do you use?
Bitbucket, Canvas.
Canvas, right? Yeah. So we use Brightspace. So if you use Brightspace, I can give you a quick dump much more easily because it's it's Desire to Learn is the company that produces it. But I can just dump the files and send you all the stuff if you want. Now this is the course that I teach. I've taught Umple at the undergraduate level, at the fourth year level, and other people have taught it at the graduate level as part of a master's model-driven development stuff. So there's a variety of people around the world who've developed pieces of syllabus. But I've been approached by Springer to write a book that would be a textbook that would essentially encapsulate all that stuff. So I'm hoping to work on that in the next year. But in the meanwhile, I can give you a dump of all the material. It's not all written by me.
Okay.
It's by a team of professors because I've adapted stuff from other people. So the reason why it's not the teaching material is not open source is because I've been sent files by other people. But they'll give me permission to send it to other professors, and so I can give you a dump.
Nice. I'll send you an email today.
Sure.
Thank you.
5 minutes left for additional questions.
Have you had experience teaching or using it also in an industry setting, or other people? Do you know of their
Yes.
experience using
Right.
it in industry settings?
So I am familiar with the university's IT staff using it, as I said, for the exam scheduling, because I help them with that. I'm also familiar with it being used in some small startups in the Ottawa area, because I've, members of my team have consulted with them and have worked for them with Umple. I am familiar with it being used in, as I said, at least one large US bank, because they've asked me to make fixes to make sure that it's more secure. And I'm familiar with a large number of downloads. I mean, I know how much is being used Umple Online, but I don't know how much is being used as strictly the compiler. So we don't, some people have said, well, I should put a webhook in, the little hook that will send me a little message every time somebody compiles something. But I said, I'm going to be ethical about this and not do that. So right now I only have anecdotal evidence that where it's being used. And I'm not quite sure how to gather the broader data. It hasn't shown up yet in the the big websites that list popular languages, and I wouldn't expect it to, but I know it's being used by some people in industry, because I do get issues raised every now and then. As I said, the security ones don't show. The non-security ones, you can look through the issue list and you can see them. The security ones, they email me directly, because that's best practice.
When can we expect the Python version of the language?
It's a good question. My next target is to have a summer student work on that in summer of 2021, because that's just the current plan. I mean, I've been building this thing. My team has been building this thing since 2007. It's a long range project. It's not a jump on the thing. But on the other hand, it's open source. So heck, you can do that if you want. One of the things that I'm thinking of using is a transpiler, as opposed to native. I want to see if we can do it with a transpiler. I had a team use a transpiler to transpile the generated Java into C#, and they built a C# system with Umple. So just basically generate the Java and then output it to C# and run it on .NET. It worked. I haven't tried that yet with Python. What I might do is one of the things you want to be able to do is embed native Python methods, right? So the transpiler would transpile all of the generated Umple code, and then it would inject in the methods that you've written separately, so they don't get translated after the fact. And then it would apply the aspects on everything after that. So it's not non-trivial, but the patterns, the code generation patterns would require some tuning to make it work. But I think that would be the easiest approach, as opposed to because one of the challenges we have is with the C++ generator, the original approach was we took the Java and we just simply translated all of the templates, but it didn't work for C++ because the syntax was too different. For Ruby, we turned the Java generator into a Ruby generator. The expert did that in a week, right? He just took all the templates, of which there were about 300 or 400 at the time, and he just he used TXL as a translator, translated them all, outputted them, and then tuned them till they were valid Ruby. But unfortunately, we haven't maintained a Ruby for all the features since then, and partly because Ruby has its own native state machine gem, so we didn't bother to implement state machines in Ruby because Ruby have other ways of doing that. So today, if we were taking a new language, it would be more work than it was in 2009. if we would attempt simply to try to translate the templates. But, you know, it's a project for next summer. So.
Looking forward to it. Thank you.
Good. Thank you.
Well, we're out of time. And so I think it would be good to stop at this point. Thank you, everybody, for joining me. And feel free to, I mean, I would, if people are interested in Umple, go on the Umple Facebook page and like it, and like it on GitHub and things like that, because you know, increase the visibility. And if people want to help bootstrapping courses, or you know, and if you encounter issues, you know, raise them. You know, I encourage people. I mean, we don't have, actually, I don't mind having a bunch of bugs, because then any new person starts, I can get them to fix them. The problem I have right now, actually, is that we don't have any serious bugs that are simple, that a new student can start. All of the issues are really, you know, either edge cases, bug edge cases and complex cases, or feature requests. So feel free to use it and report stuff and request stuff. And there's also a Stack Overflow page with tag Umple. You can ask questions there, or have your students do that. Isn't being used very much, but it's available. So as I think I showed you this this thing. So there's, you know, these are all the things. There's some YouTube videos, and this will be added to that. There's a Wikipedia page that hasn't changed much, but it's basic. There's a couple of mailing lists that have a certain low level of traffic. Lots of papers. We have if we go to researchers and click on publications, we've been publishing steadily about this. It's not my only line of research. I also research enterprise architecture and software engineering education in general. But these are links to all of the scientific papers about this that we published, including PhD theses and master's theses. So combined together right now, it's 15, and we have another one about to submit shortly. Okay, I'm gonna have to wrap this up. So I'm gonna bring myself back to Zoom, and I will stop share, and I will click on leave, and I think that will start the video recording. Bye-bye, everybody.
Bye. Thanks.